Hi, Rahul.
Hi Sunil, how are you?
Good. How are you? Hi. Happy Thursday.
Yep.
One more day and it's weekend.
I'm also waiting.
Yes.
Let's wait for some more time. Let's other people also join. I think few people are going to travel today, so might be they will not join. Let's see how many got joined, how many members are going to join. So we'll give 4-5 minutes. Okay, so I got the email from Adel that he will be late. I got email from Francis, he will be also late. Okay, so let's see, give 2 more minutes, then probably we'll start.
Okay. Awesome. Can I ask you a favor while we wait?
Yeah, go ahead.
I can share my screen and we can just get one instance running for me. Yeah, I tried that and it's something happened and it didn't work. So it should be very basic, but let's do that. So I'm going to share my screen. You can see the.
Yeah, I can.
Yeah. Okay, so let's just create like a new C2 instance. So.
Yep.
And let's just connect and I will call this DevOps.
Otherwise, today we are going to start a EC2 instance for our Docker class, Sunil. So if you are going to intend it for that purpose only, so you can follow along with me.
Okay. Yes, it is that, but I don't know if you are waiting, we can just take care of this. Is it Ubuntu or?
That's fine. That's fine. Try creating
okay.
it. Pick Red Hat 1. Pick Red Hat 1. Yep.
And 64.
That's fine. Yeah, this is also fine.
And I will use my key pair I have. Okay.
This one is important. Just pick this one. Edit.
So I'm going to use. These are the one we created earlier, and maybe I want.
So the VPC one is something that we are using. So choose the VPC
one, right?
Yeah. And submit the public. Submit.
Okay.
Yep.
And we'll
enable it. Yes. Okay. Security group. Choose your security group, which we are using.
Yeah, I remember.
That's fine. Yeah, pick that one.
And
this is fine. Whatever, if you want to increase it.
Yeah, it's free anyway. 20.
Yeah, right? That's fine. Yeah.
And then launch it right now.
Anyway, till now nobody got joined, so might be you will be alone when started.
Oh, let's do this. And I just want to see I can connect this, right?
Yeah, try it. You should be able to connect if all good. Choose your key.
Yeah, I did that. And then open. And so maybe it's launching. Connection diffused. Okay, close this one. Close this one. Okay, try it again. Just hold for a moment. Let initial checks complete. Right? Yeah. Okay. Yep. Put this one here and then go in SSH. Yeah. Auth. Choose your key. Okay. Click on open, right? Open. Yeah.
You're right. It needs reload up and then password or root, right?
No, it's a EC2-user.
Like this?
No, EC2-user.
Oh, okay, sorry. Yeah.
Yeah.
Okay, sorry. Okay, so
Yeah.
that's so this is what we'll use. Okay. But yeah, you can take over. And looks like nobody else joined, huh? Nobody.
Yeah, I think only we will be there. I got 2 email. 2-3 people are just referring recording anyway. So two are, two are going to late. I got email. They are traveling. Okay, so that's fine, I think.
Okay.
Okay. Apart from that, any other questions, Sunil?
No. I think it was just like I was getting frustrated that I was not waiting enough time for the instance to stabilize, and that is what explains it, And now I know what the problem is. Okay, this is
Yep. Okay. Let me share my screen. Okay. So. Okay. So yesterday, I think we should start. It's almost 6 minutes. So, other people anyway going to refer the recording. So let's start it. Okay. So yesterday, remember a few things was left out that we have to, we have to cover the, the DevOps, right? Introduction to DevOps that I need to complete. Okay. And then we'll jump on day 3. So day 3 is very important where we are going to discuss about the Docker, right? How the container works, installation. Then if if you would like to follow, you can follow with me. But a lot of practicals are going to be there. Okay.
right.
So let's complete this theoretical part first. The DevOps things I'll just complete it and then we'll progress further. Okay.
Yeah. Okay.
Okay, so the very first one that we are going to complete is okay. So the very first one, we are going to talk about is DevOps, right? What exactly the DevOps is? We will be discussing on that part actually. Okay, so let's see what we have here. Okay, so the how DevOps is a bit different, right? So initially the main concept was that the development and operation team used to be in a separated two different zones they used to work. Okay, now if you ask me simple and straightforward answer what exactly the DevOps, so the very first thing that you should understand that it's not a kind of skill set actually. Okay, that's very first thing that should be, you people should be aware that it's a it's not skill set. Basically it's a it's a culture that we are following actually. Okay, so you can see here DevOps is a software engineering culture and practice that aims at unifying software development and software operations. Yeah, so basically soft development and operation both got attached together. Both the teams are attached together and they are working in the same team. Okay, that's a concept of DevOps actually, but still it is if you go on real time and on ground, you will see there are a lot of different way people are working. But ideally, if you ask me, ideally this is way the people should work, that the development and operation team should work in the same team, and they should try to increase increase the a software development program, whatever the way they can do. Okay, we'll talk about what exactly the problem was there earlier, why the DevOps again, that the whenever we are discussing anything, right? So why DevOps? What DevOps? And how DevOps? So why, what, how? All these are the questions, right? We have to try to try getting answers of these all the uh, how, what, and uh, when, and all these things, right? We'll try to get the answer. So first thing is DevOps. DevOps is nothing but development and operation. Two different teams are there who they are working in collaboration, and uh, in one team. That's same thing is called as a DevOps. Okay, so now very first thing, as I said, you have to remember that it's not a skill set, right? It's a culture. It's a culture and practice that we are following actually. How these works are not new actually. Okay, you have to understand that there is not a new work that are new work or something is being done. Only the way how you are working, that is being changed actually. Okay, so only the way how you are working, that is being changed. Okay, so now when I'm saying uh, a culture, right? So you can see here the culture of collaboration between development and operation, and the practices which support the goals of DevOps culture. Okay, so somehow the software development can be easy, and the speed we can achieve the speed into the software development. That's the reason we are using the DevOps. We'll talk about, it's all about the tooling, what DevOps tools are there, how different toolings are there, for what purpose, which tool is being used. Those are all the things we are going to discuss about it. And we'll discuss one more thing, like what is the where exactly the cloud fits, because we are talking about the cloud as well, right? So we are going to see that one as well, where exactly that cloud fits actually. Okay, so DevOps and cloud, those things we'll also try to explore. Okay, so the very first one, right? So as I said, development and operation, two different teams are there. Okay, now if you see here, the you know basically why the development and operation teams are working, right? So development team will always focus on the speed, right? They are developers, right? They will try to build as much as code and make and release them in a production test environments, and then production follow on. Yeah, so basically because their primary responsibility to prepare the code and release it, right? So they will always focus on the speed. At the other hand, operation team, like this one I'm talking about, why DevOps actually needed. Okay, so how exactly it is happening in the in past, and how it's happening now actually. Now if you see this picture, actually this briefs you everything, right? There is two different opposition is there, right? Totally opposite goals are there that development and operation team have. Development team have the speed. At the same time, operations have the stability. Operation will also always think that don't push too much changes into the production, because if you push the changes or different releases in production, instability will come, right? That and the operation team will never like it. Okay, so they will always focus on the stability, right? Now if you want stability, or always your speed will be compromised, right? Or if you want to focus on the speed, your stability will be compromised. Right now, because these both the teams are two very important, um, the legs are any software legs. These two teams are very important legs of your software development. Okay, so uh, that's how actually we have started. That's how the DevOps culture have been started actually. Okay, because there is the two different team. They are working for the different opposite goals, and they will always clash. There will be always clash between them. Okay, so to remove those classes actually, or to reduce those classes, DevOps culture have been started. So we'll see what classes were there, how we have achieved this. Okay, so now if you see here, now if I'm combining both the teams, right, development and operation, now the shared responsibility is speed and stability, right? So you see here, speed and stability both are required for any software development, right? I don't want to break the existing environment. At the same time, I don't want to compromise on the speed as well, right? How you can achieve this? This can be achieved best way only if both the teams are working into the collaboration and coherence actually. Okay, so that's how, that's only that way actually you can achieve. So that's the reason actually why DevOps culture have been implemented. Okay, so they have started, and these time actually, so almost all the industry is moving towards DevOps. Okay, so DevOps, this is the reason why DevOps have been implemented. Okay, now we got to know what exactly DevOps, right? Why DevOps? That one way I've tried to give you answer. Another way, what goals are there? Basically, why we want to implement DevOps, right? What we can achieve by implementing DevOps. Okay, so you can see here there is a both the teams are working in the same team, same goal. They are sharing the same goals as well. That's very important. Okay, and the main reason is fast time to market, right? TTM, that's a value actually, that's a calculation value is there. Basically TTM means how early you're building your releases, how early you're building your codes and release into the production, right? That's the total time to market. Okay, so if I'm saying that you should not compromise your stability, at the same time you can do the faster releases as well, then the solution is DevOps. Okay, if you want to both, you want to achieve both. You can see here few production failures, means the production failures will be should be very less. If you want to achieve all these things, DevOps is one of the solution. Okay, and immediate recovery from failures. Okay, now when I'm saying immediate recovery from failures, right? How I can achieve this? I know that by saying that the immediate recovery is easy, but it's not so straightforward. Okay, so if I'm saying that the immediate recovery I need, for that purpose, I have to implement few functions in our that your monitoring should be very tight, your alert system should be very good, that you should be immediately getting alerts. All these systems should be very good, right? We'll talk about how alert can be how monitoring and alert can be set up, so that the monitoring and alert systems have very good way, working very good way. Okay, now, so when I'm talking about 10-15 years back, when the DevOps culture was not there, okay, how different teams was working, right? How different teams was working. Remember, development and operation used to be in a separate team. Okay, now you can see here there used to be another team called QA. Okay, so development, QA, and operation, all these three teams used to be there actually. Okay, so now you can
Yeah.
see here sorry, yeah,
No,
Sunil.
no, sorry. Yeah, go ahead. Yeah, sorry. Yeah.
Okay, so they all are different teams. Now you can see here, let's suppose developer have built some code, he will send to the QA team. Okay, QA team will see if there is some problem, they will revert it back. Okay, then developer will fix that issue, he will send it back to QA. Let's suppose QA sent to the operation. Now operation team finds some issues, so he will again revert to the developer or QA. So this all round of function was going on actually. Okay, this all the round function was going on. Okay, then to remediate these issues, we have implemented, DevOps culture have been implemented actually. Now you can see here the similar thing is being shared, you know. Okay, now you can see here all are working in the same team: development, developer, QA, and operation. And these days, when I'm talking to you, most of the functions are automated actually. So you can see here, building, integration, testing, and deployment, right? All are mostly it's automated. That we when we talk about Jenkins, at the same time I'll talk about this one as well, why I'm saying it's automated actually. So automated means if a developer have pushed the code, if developer have changed some code and he pushed the code, automatically that will be tested, okay, and automatically get deployed as well. Okay, operation team, it means that and if there is any fault, there is a testing division that will be get sorted out there in the testing division itself. And if it is fail, it will be reverted from that point so that developer can fix their code and resubmit it. Okay, so that's how these things are implemented. Okay, all these three building integration, all are automated these days. Okay, I'll show you as well how exactly the automation works. Okay, when we will be in the Jenkins, so you'll get to know that if I'm submitting some code at the source repository, immediately that will be picked up. Okay, now when remember one thing I said, that when I'm taking a DevOps name, that uh, we should be able to fix any issues as soon as possible, right? When I'm saying that we have to fix any issues immediately or as soon as possible, so we have to make sure that the monitoring is very strong. Okay, we have to make sure that the monitoring is so strong so that it can immediately pick up any fault, and at the same time alerting also should be on the on the fly, so that alerting to correct people and with the speed is very important, so that if there is, let's suppose, any automated function is there. Okay, you have converted, okay, something gonna happen. Okay, kick let's kick the automated function, which will just, let's suppose, any service got down or something, right? So there is two way. Either you can fix it automated way, right? Either you alert to the person, right? So both things should be configured in a way that immediately it should be picked up. Okay, so for success of any application or any production system, the monitoring is the key. Okay, you have to see how you can achieve your monitoring. We'll talk about, there is a different tools are available actually, which can help you to monitoring your system best. Monitoring, we'll talk about which is the good one, which the mostly people are utilizing. All those things we are going to talk about. Okay, so yeah, and if, let's suppose, we this ideal scenario, right, and we have implemented this ideal scenario, so then what will happen? Happiest team and the happiest customer as well. Okay, so but again, this is the ideal scenario. It's not necessary that every time it will happen, but yeah, ideal case is there that if you are people are implementing that, the reason behind it, the implementation is that the teams will be also happy and the customers should also be happy actually. And at the same time, how you can make sure that the customer will be always happy if their stability is not being compromised, and at the same time you are making sure that the speed is also maintained. Obviously they will be happy, right? They what they need, right? And the teams, actually there is a different a bit. I would say that the earlier there used to be a development and operation, both are different skill set actually, but now they are working in combination, so a bit training and all those things are required. But yeah, that's a need actually these days, so people are working in the similar kind of environment where they need a bit development as well as the operation skill set. So if there is a pure developer, he need to understand bit operation things, and at the same time, if there is a operation a member, he need to understand bit development skill set as well. Okay, now one thing which is very important, that there is a periodic table for the tool section. Okay, so I'll not talk about tools for now. Okay, there is a there is a periodic table for the tools, DevOps tools, but I'll not talk about right away. I'll talk about in some time actually. Okay, now before I understand, before I say, okay, so you have to understand what exactly the pipeline. Okay, before I start to the so in DevOps actually, let me show you. So this one, right? When I was saying that the building, integration, testing, and deploy and monitoring, right? All are being done by automated way. Okay. So automated way means you're writing some code, which code actually taking care the building integration, testing, and deploy, or everything is being taken care by the code actually. Okay. So the code which is being retained to take care of all these things, that's called a pipeline actually. Okay. So pipeline means you're writing a pipeline where different stages you're writing. You're saying, okay, this stage, let's do the build. Okay. If build is successful, let's do the testing. If test successful, let's go for the deployment, right? And if the deploy is successful, let's keep monitoring. Okay. Now, if anything got failed at any point of any junction, you will just revert or you will fail your pipeline. Okay, that's how the pipeline actually works. Okay, so for pipeline there is a Jenkins. I'll talk about on the Jenkins part later. Okay, but right now just understand the pipeline. Okay, now in pipeline, what all the stages are there? What different stages are there? Now you can see here. So the very first one will start from the coding. You can see on the top, right? So coding is the very first thing. Means a developer is there. Okay, before code actually there will be planning, obviously, like what all the things, what exactly you're going to do actually. Okay, so how you are going to do, what tools that you are going to use, right? All those things are the planning section. Once you have done your planning, the next section would be code. Code means you're writing some code actually, which code need to be deployed. Now remember, whatever things we are talking about here, it's basically, if I'm saying a pipeline, right? Pipeline is nothing but deploy some code. Okay, now let's suppose you must be thinking, what exactly deployment, why we are using the pipeline. Okay, now think about, there is a website, Amazon. You can take an example of Amazon itself, right? So Amazon, if you go on Amazon website, there are a lot of features are there, right? A lot of prices are there, and that too there is a dynamic prices that keep changing, right? There are a lot of the front page, there is a the child pages, a lot of things are attached to it, right? So how that page is being built, there is a code actually in the backside, which code running in a format of um, a website, I would say. Okay, a website is running, there is a backend, some codes are there that basically works as a a website, right? Now for that purpose, now let's suppose somebody saying that I need to change a website, right? The Amazon website, I need to add some more feature. So what I have to do it, I have to deploy some code there, right? Some code changes I have to do. Okay, so there is a procedure actually to change anything. Okay, that basically that procedure are being taken care via pipeline system. Okay, so that procedure is being taken care via pipeline itself. Okay, so the very first section is plan. Okay, this one is very famous pipeline, uh, a pipeline, a very famous, I would say, that the feature. Okay, now let me just open this notepad.
So Rahul, a quick question, right?
Yeah, please.
What are like the AWS specific services for DevOps, right? So AWS itself is one of the component in that chart you have.
Right.
But what else? What else is there? Like, what does the AWS provide that
Right.
I cannot have in my own on-premise? Let's just say I build a DevOps pipeline in my own computer center, right? In my own thing, there is no AWS, and I can still have the Maven and Jenkins and everything that you mentioned here, right? But
Right.
what I mean, I'm just curious on what are like the AWS has their own way of doing, what are the additional things that AWS specifically comes out in the box? Yeah.
Okay, so AWS have solution for everything. Sunil. Okay, remember on day one, when I was talking about certification, I mentioned to you that if you're going for DevOps is different section. Okay. And if I'm saying it's AWS DevOps, okay, this one is a bit different. Why I'm saying, okay, so in general DevOps, actually, in general DevOps, you can see here, like, the same way. What section will be there? Plan, then code, then build, then testing, release. I'll show you. I think that will be helpful for you. Testing, then release. Okay, deploy, operate, and monitor. Deploy, operate, and monitor. Right. So these are the phases in any DevOps. In any DevOps culture. Right. Whenever I'm implementing DevOps, these are the main function that we are utilizing. Same time, when I'm talking about AWS DevOps. Okay. So remember, if you're going for examination of AWS DevOps, okay, so the question will be asked you. That's why I told you on that day that if you're going for AWS DevOps certification, this class will not give you entire thing actually, because this class is mainly built for the AWS. If you're going for AWS solution architect or AWS SysOps, then that's fine. But if you're going for AWS DevOps, there are few different toolings are available. Okay, I'll show you. I'll list down for you and other people who are watching the recordings as well, so that you can cover those things as well, because there are particular tools are there that I'm not going to cover here in this class, but at least I'll give you idea, right? Like, if I'm saying, okay, for code, this one I'm using here in the general DevOps, what AWS will be using. Okay, in building, I'm using this, what options we have in the in AWS, right? Same way for the other things, right? I think that's the same thing you're looking for.
Yeah, like you put it really nice way. The top section and the bottom section, right? How do they differ exactly? Yeah.
Right. So we'll try to discuss on this, Sunil. Hopefully, after discussion, you will be having your answer. Okay. Now, as I said,
I think I would suggest one thing. As you take the notes in that notepad, maybe you can share that with us, and that will be very useful. You put together like this everything that you have here. Anything that is not like or something you don't want to share that. But like say that.
No, nothing.
Maybe as we go along, we can start filling that. And yeah.
I have noted down for you guys only, but yesterday I forgot to share this. I'll share today.
Okay. Sounds good. Okay, thank you. Yeah.
Okay, so okay, so let's discuss first thing first, what exactly these functions are. I'm going to talk about one by one as well, but I'll just give you idea, right? So simple way, as I said, these 8 things are there. Basically, the very first one is the planning. Once I have done the planning, I'll go for code writing, right? Code writing. Then once I have my code, that code need to be built, right? That code need to be built. Okay, so that one. Then testing is very important of any pipeline. Success, whether success or not success. If it is not success, that will be failed from here itself. Okay, once it is, let's suppose I'm saying, okay, for testing, let's suppose I'm saying the testing results is negative. Okay, immediately it will be rolled back. You have to go on a code, change your code, build it again, and test it again. If my testing results are positive, then I'll go for release. Okay, release means I'll start planning where to deploy, on which environment I need to deploy, and all those things. Once I have done that, then deployment will be coming. Okay, now deployment means I'm going to deploy. Okay, deploy means I need to deploy somewhere, right? I need some servers, some containers, somewhere. Okay, so in this place, actually, your AWS or Azure will be, all these things will be coming here. Okay, now let's talk about one by one. So the for planning, it's total manual job, right? There is no such thing that any code or something is there. For code, actually, there is a lot of tools are available. Git is there, then GitLab is there, okay, Bitbucket is there. I'll talk about others as well. Okay, these are the tools available. Now remember, in AWS or in DevOps, all things are being managed via tooling itself. Okay, now for building, you will see here they have mentioned as a building SBT or Marvin is very famous tool that you can use. Okay, there is some other tools are also available, like ants also you can use, and that is also one of the tool. Okay, for testing purpose, testing we are not doing too much because mostly developers are doing, but again for testing JUnit is or SC, these two tools are available. So SC or JUnit, anything can be utilized. Okay, for release purpose, I can use Jenkins or CodeShip. That's so Jenkins we are going to discuss. That's very famous. CodeShip is also one of the options. Deployment purpose, again, where exactly you're going to deploy. Okay, that you have to, if you talk about in release, so release itself is this section itself called continuous integration and the continuous CI and CD. I'll talk about on those things. Now, where exactly you want to deploy, right? So here your AWS, Azure, or GCP will come. Otherwise, Docker, Kubernetes, all these options are there. Actually, we'll talk about one by one. Okay, don't worry about it. Next is operate. Operate means, let's suppose my code is got deployed. Pick same example, right? Similar example which I was talking about Amazon. Okay, so for Amazon, there was some changes on the website, right? That we have posted. Now, let's suppose I need to change something. Okay, I need to change something means, let's suppose I have to, I have to do minor changes in the, on the portal, and but there are multiple servers are there. Okay, so one by one doing manual is not going to help, right? So that's called configuration operation or configuration management. Okay, for configuration management, there are multiple tools are available. Okay, so Ceph, Puppet, Ansible, all these tools are there. Okay, so we are going to talk about there is a particular topic we have for Puppet, we have Ansible, so both we will be covering. Okay, last is monitoring. Okay, monitoring means monitoring is very important, right? So if monitoring is not there, the guarantee of success will not be there. Okay, so if I want to make sure that my production systems is running fine, and if there is any failure, I am being I'm able to detect it immediately, then this is the solution actually. Okay, so monitoring is the solution. So there are a lot of tools are available. Okay, Datadog, then we have Nagios. Okay, and some other tool which is Splunk is also available. So depending, like anything can be used. Okay, so Nagios we are going to cover here in our in our class. Okay, so this is the way actually. Okay, now when I'm saying what tools are available for in AWS DevOps, right? So if you go back, I have shared you this link actually. Okay, there is a periodic table for any particular purpose. Okay, now let's try opening it, see what we are getting. Okay, so this is the periodic table we have. Okay, for all the function, what we are, what I'm talking about, right? Container, then monitoring, right? For all the functions, we have some different toolings. So I have just listed few tools, right? So it's not, it's a big world. Actually, lot of tools are available for any particular work. Okay, so I'm just talking about few tools. Okay, now let's see one by one. Okay, so planning will be always a manual, right? For planning you can't do anything. Now what about the code, right? Let's search here. What is the name? Okay, so code is also called as a source code management. Source code means a place where you're keeping actually source code, right? That's a source code management as well. So the code or source code management also you can mark it. Okay, now you can see here what all the options we have. Okay, so remember I've just mentioned 2 3, but here you can see how many got listed. Git, GitLab, GitLab SCM, Atlassian, Bitbucket. Okay, and Compuvere, okay, Subversion, lot of options are available, right? Lot of options are available. Now, AWS one is not managed. AWS one is not listed here. Okay, let's come here. Still it's coming. I just removed it. Yeah. Okay, so hmm, now you can see here. Okay, now you can see here the similar kind of things we can. Okay, now just open this one, this developer tool. That's called a developer tool. If you come on the developer tool, you will get everything. Okay, so now same way, the way we are using the code, source code deployment, source code management, right? Same way for source code management, we called as code commit. That's a tool which is available for the code source code management or coding purpose. It's called code commit. Not very, fancy name, neither it's very a lot of people are utilizing, but yeah, the options are still there. Okay, next one is the building, right? Now for build, remember what Marvin and Ant I have given you, right? Now let's see both the things. How many options are available here? If I come here, the building. Might be some different names. Are you able to see somewhere, Marvin? Let me search Marvin. Where is that Marvin? Here you go. Okay, so you can see here in this place, lot of options are there. Okay, if I'll search for ant is also there. Okay, so this is the way actually. So just remember there is a lot of options are available for building purpose. Same time, you can see here. So Marvin that can be used for build, even though your GitLab CI can be used. Okay, if you ask me Azure, so Azure DevOps code, that options is available. And if you ask me AWS, right? AWS code build, that option is available. Now, if you come here in building section, right? There is, you can see AWS code build is there.
Yeah.
Yeah. So this website is very, they keep changing these website. Okay. And you will be able to see, anyway, like, it's almost impossible for anybody to learn all the tools, but at least you can know about, right?
Yeah, let's put that link into that document too, the website link.
Yeah, document. I've already shared that link, Sunil.
In the chat.
Have you opened the document? You can see here page number 13. There is a link for periodic table.
Oh. Okay. No, I'm not following the document completely. Okay, I got it. Yeah. Okay.
Okay. So that's a code build. Now, third one is testing, right? What we got in the testing. So in my example, I have given you JUnit and SC, two tools I have given. What about periodic table? How many tools are available? If you come here, where is testing? Here you go, right? So if you click on testing, these are the testing tool. So you can see Tricentic, Tosca, right? It's hard to pronounce as well. Neoload, Selenium, JUnit, lot of tools are available. So basically what I'm trying to say here, Sunil and other people, whoever is, watching, it's almost impossible you to learn about all the things. What you can do, keep one actually. Okay, keep one, which is, famous, that you can keep one and you can keep learning about same thing. If you start working in the industry, what will happen? If you go from one company to another company or one project to another project, that there is a possibility that these tools will get changed, but the fundamental behind it will be same. So you don't have to worry about it. If you understand one tool, that's fine. For the other tool also, you will not face too much problem. Okay. Now, what about AWS? What AWS option is available? So we are talking about testing, right? I don't think they are testing something. Might be in the build itself, they are deploy pipeline. I think pipeline itself will take care the testing, might be. Okay, let's search about it. AWS testing DevOps tool. Yeah. I think code pipeline itself is doing same thing. Is it code continuous testing is a separate continuous testing? Yeah. Code pipeline itself doing, I believe so. Okay, so in pipeline itself, they have utilized for the testing purpose. Okay, so in pipeline itself, they have merged the pipeline, the whole pipeline, releasing CI/CD practice as well as the testing feature as well. Okay, so I'll mark it as a AWS code pipeline. Okay. Release also will be done with this one only, because the similar for release we are using here Jenkins we are using. On place of Jenkins, AWS code pipeline will be used here. Okay, deployment purpose, for deployment anyway, like code deploy is one of the option that you can use. Okay, and here deployment purpose. Okay, now you can see here there is two things. Okay, one is the deployment method. Okay, one is the deployment method, and another one is deployment target. Right? Why I'm saying deployment target and deployment method, two different things, because deployment target means where exactly you are deploying your code. Right? When I'm saying, remember the Amazon example which I was giving. So when I'm saying there is a difference in the code that I want to deploy. Let's suppose there is some pricing changes that I want to deploy in the AWS, right? Now, for deployment, I'll deploy it into the AWS. But what is the method that I'm going to use? Okay, so you can see here, these are target section. Okay, these are deploy targets. Okay, when I'll say deploy method, like how I'm going to deploy my code, then probably the code, then the, it will be different. Then we can use Jenkins section. Okay, then I can use Jenkins. I'll show you where our concept of CI and CD is also coming. That is very famous actually. Okay. Okay, so again, deployment target in AWS can be AWS itself you can use, right? Otherwise, Azure and GCP is not possible from here. Remember, because you are using the same platform, on place of Docker, I can use ECS, Elastic Container Service. Okay, we'll talk about that one as well. What is, I think, if you have gone through that solution architect class, you might be aware Elastic Container Service we are using as a Dockers in a clustering solution actually. So Docker we are going to talk about. Same time I'll show you ECS as well. Okay, and on place of pure Kubernetes service, obviously pure Kubernetes service also can be utilized, but most of the time you'll be using EKS. That's called Elastic Contain. What is called Kubernetes service. Kubernetes service. Okay, that's called EKS.
Amazon offering that Elastic Kubernetes is.
Right. It's all Amazon offered. Okay, that's called ECS. If you search in AWS, you'll be able to find it. Sorry, EKS. Okay, clear till here, Sunil?
Yeah, that's good. Yes.
Okay. Now deploy method, as I said, here we are using Jenkins, but here we have code deploy. Okay, AWS code deploy. So we'll be using AWS code deploy. Okay. Operation purpose, I don't think there is a different tool available that AWS is offering. Do we have anything? I don't think so. Okay, just let's verify here as well. Configuration, right? So for configuration, all these options, anything AWS you can see. I don't see Red Hat, Ansible, Terraform, Ceph. AWS Cloud Formation. That's very good actually. I missed that one. That's a provisioning service. I thought it's a provisioning, but that's fine. It can be used as a, operation purpose as well. You can use. Okay, that's very good service actually. I think AWS Cloud Formation was being covered in Solution Architect. I'll see if it's a part of this class as well. I think somewhere. So we'll talk about that one as well. AWS Cloud Formation. So for now, just focus on the names. Okay, what exactly how they work. Don't be worried about it. Later point of time, I'm going to cover, but obviously I'm not going to cover these things because, as I said, these are a bit different from this class actually. Okay, so right now I'm not going to discuss. Cloud Formation will be covered. ECS I'll be covering some till some extent, and at the same time Kubernetes I'm going to cover it in detail.
So Rahul, one question, right? If I want to go for the AWS DevOps certification, right? That is what the thing is. What approach you recommend we take? So we are going to cover some of the Jenkins and other things, right? Some of the other things that's in the top segment. And what would you recommend? So I know you took that exam recently, right? About a year back or 2 years back, right?
That's correct. That's correct.
The AWS DevOps, the challenges on that. So what do you recommend to we take, the approach I take, so I can have chances of success are higher, there are no guarantees,
Right. So Sunil, how you can do that? There is a two form, right? For AWS DevOps. One is base of AWS that we are anyway covering, right? That we are almost half of the class is going for the base of AWS, right? Like that platform as service, infrastructure as service, and etc. Right? So those things will be always part of your examination. The question will be coming. Then monitoring is one of the section. Monitoring also we are going to cover. These few 3-4 topics on place of like code, build, testing, release, and deploy, right? These 2-3 things are different that we are going to talk about here in this class because it's intended for DevOps, general DevOps as well, if anybody is targeting. So on place of, if you because you are already getting this information, you can start exploring these things as well. The code pipeline, just try to build one pipeline, because I'm going to show you pipeline, how pipeline works here in the journal if you're using Jenkins, right? Now what you can do on once you do the Jenkins, once you know how the pipeline works, then you can start deploying something in the AWS code pipeline. Okay. Now why why I'm saying why the Jenkins is part of this class actually, because if you go outside, right, if you go for the job, okay, till now, as from the experience that I have seen, 99% places people are using Jenkins only. Jenkins are, they're basically what I'm trying to say. These AWS DevOps tools are not very famous. Public are not using, even though if you are using AWS for your entire infrastructure and all those things, but for DevOps purpose, they are using this, these services. Reason behind it, because most of the services are free, actually, open source, and they are very good in the service. That's why people are using like Jenkins, Ansible, all are very good in the service. Kubernetes is free. That's a huge benefit that, Google have offered, right? So that's why people are going for these free services, open source services. They are customizing in their way, and and if you are using AWS tools like code build, code pipeline, you have to pay to the AWS, right? That's why people are going for the free one.
Right.
Okay.
No, I agree. Yeah, I hear Jenkins a lot and a lot of job requirements I see. So I agree.
Lot of if you understand Jenkins properly, the pipeline, you got to understand there is a huge demand in there.
That's true. That alone can be a career path.
Yep.
Yes, I agree. Yeah.
Okay. For monitoring purpose in AWS, we have AWS CloudWatch. Okay. So CloudWatch I have already covered in Solution Architect. I think till some extent I'll be covering here. Okay. Hopefully now I'm able to answer your question, which initially you asked, how the differentiate.
Oh, no, in very well detailed. Thank you for, yes.
Okay, I'll share these things with you. Everyone, obviously, on the email I'll share. So I think someone got joined. Adel got joined. Hey, Adel.
Yeah, hi, how you doing?
Yeah, I'm doing good. So, Amit, you can refer the recordings. We have started at the same time. So whatever the things are there, that you can refer the recordings. Yeah.
Sure, thank you.
Thank you. Thanks, Adel. Okay, so these are this is picture actually, which which is mentioning what all the things are there that is being covered, what tools are there. Okay, so in this tool, if I talk about, so from code, Git will be using, will in our example, will cover Git. Then Marvin is not being used. Building and testing will not be utilized too much. Okay. Then Jenkins will be using, will then Docker and AWS we are going to cover. From configuration management and Ansible, I'm going to cover. Kubernetes is also going to cover. Puppet is not mentioned, but Puppet is also there, that will cover as well. Okay, and from monitoring, Nagios is going to be covered. Okay, and AWS CloudWatch will cover. Okay. So these are the tools that we are going to learn one by one. There is a Terraform is not mentioned here, which is very famous tool these days for the infrastructure as code, that also we are going to cover. So the way you are mentioning Jenkins, right? Same way the Terraform is also very huge in demand. So if you understand Terraform, that is also very good. So we'll try to cover that one.
Terraform?
Sorry, Sunil?
What was that again? Which one?
Terraform.
Terraform.
Yeah, we'll cover that one. I'll tell you what exactly the benefit. So whatever things we are doing in AWS, right? You're creating EC2 instance and whatever you're doing, anything can be done using Terraform. Okay. So you don't have to log into AWS. Okay. And your Terraform will create your instance from outside. Automation.
Right.
So that way we are going to cover. Okay, now we'll focus on the continuous integration. Okay, so let's have a break. Okay, let's have a break for for 10 minutes. Come back and then we'll start it again.
Okay, sounds good.
Yeah. Okay, sounds good. I'll see you soon.
I'm back, guys.
Yeah, I'm here.
Let's start then. Sunil, you also there? Okay, just give 1 minute to Adel. Let him also join.
Sure.
Sunil, you join? Sunil? Okay, you might get stuck somewhere. Let's get started.
Okay.
Almost 10 minutes. Okay, so the next one that we are going to talk about two different concepts. One is the CI, another one is the CD. Okay, I think I have tried to prepare something. Okay, let's discuss first the definition, then I'll come on that, the diagram which I prepared. Okay, so what is continuous integration? Okay, so you can see here the practice of frequently merging code changes done by the developers. Simple layman terms, right? Now, if I'll try to brief it in more detail, if you come on this picture, right? So this picture, okay, where I'm saying the code is here, code is being built and test and released, right? So there is a continuous integration process. When I'm saying continuous integration, let's suppose the code is one code and there are multiple developers are working, right? All developers will try to push their changes. Okay, all developers will try to push their changes into the master repository, right? How it is being managed, who actually manage? Okay, so that's something Jenkins is managing. Okay, so basically Jenkins, I'll not take the name of Jenkins for now. I'll talk about the continuous integration. Okay, so continuous integration is a way that, let's suppose 10 different people are working. Okay, they are pushing their codes into the main master repository. It is being picked up and pushed towards for the deployment, right? That's a procedure called continuous integration. So continuous integration is nothing but the picking the code and deploy. So CI and CD, you will be whenever you'll see any requirement for DevOps, that's very common. You will see everywhere that the requirement is coming for the CI and CD. So CI stand for continuous integration. Continuous integration, nothing but just merging your codes. Like let's suppose me, Sunil, Adel, other people, all are working, Francis, right? Everyone is working and they are pushing their code into the master repository. Okay, so Jenkins will keep picking it up, whoever is pushed, and it will be pushed for the deployment, push for the end deployment. Okay, that's how it is being achieved. So that's called a continuous integration actually. Okay, this is the picture actually where entire thing, how the continuous integration and the continuous integration and deployment, continuous deploy is being completed. I'll talk about here, okay, later. First of all, just try to understand the CI, continuous integration. So you can see here traditionally the developer would work separately, perhaps works weeks at a time and then merge all their work together at end of large effort, right? Continuous integration means merging constantly, okay, throughout the day. Means whenever, let's suppose I have done my changes, same time I'll be pushed, right? That's how the continuous integration works actually. Okay, so this occurs multiple a day. Just go through it. Okay, why we are using continuous integration these days? Whenever I'm talking about DevOps, so continuous integration is need. Without continuous integration, you cannot survive actually. Okay, so understanding continuous integration is very much important. Whenever there is a merge, in a code, whenever a developer will push their code, immediately it will be picked up by your integration server and pushed for the deployment. That's how your continuous integration works actually. Okay, continuous integration works. Now, why we are using it? Similar kind of requirement for the way we are deploying. We are saying for the DevOps, early detection, elimination, the scramble, if there is any bad thing into the code, right? Continuous testing, good coding practice, encourage good coding practice, right? All these are the basics. All these are the basics why we are using it actually. Okay, now in the same way, there is another topic called continuous delivery and continuous deployment actually. So continuous delivery means now the code got picked up for delivery. You picked up the code, okay, and once the code is ready, you are going further. You're making it build and it's ready for deployment actually. Okay, that's called the continuous delivery. If my code is ready for deploy, that's a continuous delivery. And if I'm pushing for the deployment final stage, okay, I'm saying, okay, let's go and deploy into the server. Okay, that's called as a continuous deployment. So continuous delivery and continuous deployment, there is a very minor difference. Continuous delivery is holding your code in a way that whenever it's needed, it can be deployed. And continuous deployment is the last stage where you are just deploying it actually. Okay, so these are the just definition. Go through it. I'll not try to brief you here. I'll rather brief you from here actually. Okay, this one, there is another sheet I've shared with you. So I'll brief you from here. This one will be better brief you. Now you can see here, this is nothing but the same 8 picture which I have shown you for DevOps, right? AWS DevOps. The similar kind of things we are going to do it here as well. Now you can take an example. Of Amazon itself. Let's suppose Amazon, right? Amazon website is there where we now think about that the Amazon is already running, right? There are a lot of changes in a day. Thousands of people are working to keep changing it, right? 1,000 developers are there. They keep changing some code and keep deploying something, right? For that purpose, in actually production, it's not so frequent that the deployment will not happen so frequent, but in UAT or test environment, the developments are happening very frequently. Okay, in a day, people are deploying multiple times actually. Okay, now how that entire process works. Okay, Okay, those things is all on this. Those things you can cover from here. Now you can see here, as I said, there as well. Now if you come here in this way, I said, right, these are the stages. The very first thing is planning, right? Where I'm saying that the how the deployment, how that entire pipeline will work, right? That's the first section. Okay, similar, the very first section, then it will be coming here some, the very first one. Okay, then second one is the code where you're actually writing your code. Okay, this is the section, the second one. Okay, Then next one is CI. So, here before building, actually, this before building and testing, this entire section will be into the CI, actually, continuous integration, because continuous integration you will not see directly here in this section, but continuous integration is there because if you're just deploying one time, fine, continuous integration is not needed. But there are multiple developers who are pushing their codes multiple times in a day, right? That's the reason the CI, a continuous integration, is needed actually. Okay, so Git, then next one is the continuous integration, where Jenkins will pick up your code. Okay, then building will be done. Now, what tools are there? Maven, Gradle, NPM, even though Ant I have mentioned, right? All these tools are available. Then testing. Okay, testing is the key point here. If your test is successful, fine. Otherwise, if test is not successful, immediately it will be moved back to the Git. Okay, it will be asked that the go for the check your code again. Okay, and if this is good, it will be pushed for the continuous delivery, where we'll say that okay, my code is all built, tested, and my code is already ready now. Okay, and that's a continuous delivery section. Okay, now if I say yes, okay, go ahead and build it, it will just go and deploy it on the EC2, Amazon EC2, or it can be container or anything that we can pick here. Okay, and the monitoring is the last section. So continuous integration and continuous delivery and continuous deployment, three different terms are there. Always remember CI, CD, continuous integration, continuous delivery and deployment. Okay, these are very common questions. If you go for interview, people are generally asking. Okay, so just make sure that you are you understand that one. Anyway, when we'll do the Jenkins section, I'll try to show you on the ground as well how exactly it works. When I'm saying continuous integration, continuous deployment, how exactly it works. Yeah. Okay. Now, next one is configuration management, right? So where exactly your configuration management will be coming? Configuration management is, okay, I'll try to put the different names as well. What we are so this code is there, which we are calling it as a source code management as well. Source code management. Okay. Building is fine. Continuous build as well. Sometimes we are saying is a continuous build. Okay. This one, sometime we are saying as a continuous testing. So why I'm saying sometimes these things will not match exactly what you're looking for. So just make sure you're aware about, okay, this is the release section actually. At this section will be meeting continuous CI and CD. Continuous integration. And continuous delivery. Continuous deployment. Okay. Deploy targets is fine. Deploy method is also fine that Jenkins will be using. Operate, right? This one is called as a configuration management as well. Configuration management. I'll just tell you why we are calling as a configuration management. Monitoring, sometimes we are calling as a continuous monitoring as well. Okay, now where we were on the operate or configuration management, right? Why we are saying it's a operate and configuration management, both are different. Both are not different actually. Operate means, let's suppose I want to operate something. Okay, I want to operate something. I something is already running. Okay, I want to do some operation there. Okay. Now, same time, configuration management. When I'm saying a config, I told you, right? Let's suppose there are 100 servers out there. Let's suppose just host name you have to change. Simple. Okay. If the just host name need to be changed, what you will be doing? Okay. For that purpose, because the manually host name changing is a very painful job, right? Then you can utilize some of these configuration management tools, okay, which can help you to change the host name on all the machines, okay, at one go. That's why it's called as a configuration management. It means that you're changing configuration in automated and multiple servers. That's called a configuration management actually. Okay, I'll show you. As I said, Puppet and Sybil, both we are going to cover as a configuration management. Okay, and we'll see how they work actually. So if we have to change it, how we can change it on the multiple servers. Okay, the if you see the definition of it, what it is called: maintaining and changing the state of piece of infrastructure in a consistent, maintainable, and stable way. Right. So we can see here the similar thing which I'm trying to brief you. The similar thing is given some in a typical language. Right. Maintaining, changing the state piece of infrastructure. It means something is already there in the infrastructure which is running, and I'm changing with the I'm changing in a stable way. When I'm saying stable way means that the I'm making sure that there is nothing got broken. Okay, and the multiple changes. There are multiple servers are there. All got changed at one go. I don't have to worry about it. So I'll show you how Ansible works, how Puppet works. Like if let's suppose simple, I want to install something. Okay, for installation purpose, I'll go for one by one. Then it's very painful job, right? For installation, if I just have to do the installation on one machine, it's fine, right? But if I have to do the similar kind of installation on the multiple machines, then obviously we have to, we have to do some automated way. Okay, so that we are going to learn in one of the tool that I'll show you in both the tools actually. Okay, so just go through some, the reasons why we are implementing: save time, insight, maintainability, less configuration drift, right? This is very important actually. Less configuration drift. Okay, when I'm saying less configuration drift, why I'm saying, because think about, right? So manually doing, if you're doing manually on many servers, there will be always possibility of fault, right? There will be always possibility that you miss something, and you miss something to update or miss something to do on some servers. So there will be always some drift. Okay, if you're doing an automated or using some application, then that you can avoid that drift actually. Okay, the last section is monitoring. Okay, you can see here monitoring, that's called continuous monitoring as well. When I'm saying continuous monitoring means you're making sure that your system is continuously monitored, right? There is no drift, and you're continuously monitoring it. Continuously monitoring means any particular time, 24/7, 365 per days, your monitoring system is properly working and alert system is also working. Only monitoring is not going to help until unless the alerting is, not proper. Okay, so alerting also should be best way. So we'll see. There is a different tools are there actually. Now, what exactly the monitoring? Monitoring means whatever your infrastructure, right? So servers monitoring is one thing. Now let's suppose server got down. It's that's a major event, right? But apart from those monitoring, there is a minor monitorings are also available, like the CPU information, network statistic, then disk IO, right? And application logs, traffics, network traffics, etc., memory usage, right? All these monitoring is also important at the same time, because these can land up in a situation where your system got crashed, your system will crash. So basically system will always give you some hint if there is let's suppose the usage is going high, right? That's very common situation where the usage is going high. So if you are not fixing those issues in advance, you'll be you land in that situation where your system will be crashed in one day. So you have to always keep an eye on this. That's why monitoring is very, very important for your, successful production system. Okay, so monitoring is obviously is being used for real-time notification. If there is anything anything got happen, immediately the notification. As I said, only monitoring is not going to help until unless you do the notification, until unless you do the alert notification. Okay, so we can see, we'll see here in CloudWatch. There is a section actually. Right now I'm just focusing what exactly the monitoring, how you can do the monitoring, and all those things will try to cover. Okay, then one more very important term why we are using monitoring is post-mortem analysis, right? Post-mortem analysis means your machine got down. Okay, machine came up. Okay, your server restarted and came up, but you want to know what exactly happened, why it got down actually. Okay, why exactly happened. So that post-mortem things as well can be done with using monitoring. Okay, so what benefit, why we are using, and those things just go through. Toolings, I have already briefed you what tools we are using, like for build automation. Continuous build, or sometimes we are saying it's a build automation as well. Okay, so build automation. Okay, so Marvin, and there are a lot of tools are available. Basically, you can see Marvin, and Gradle is also available. A lot of tools are there. Depending on your need, actually, you can use the tools. Okay, for testing. So the tooling is just brief here, because anyway I've just covered the tooling, so I'll not go through again. Anyway, I'm going to cover it entirely one by one, so I'll not go through one by one that. Tools for monitoring, as I said, I'm going to cover data Nagios and AWS CloudWatch, both we are going to cover. Okay, one very important things before we close actually. See here, I've mentioned this one. I think Sunil, you were asking, right? Code build, code deploy, code pipeline. I've already mentioned here actually. Okay, in the document itself. Sunil, you're there, right? Okay, I think he went into the mute. You're able to hear, right, Adel?
Yes, I am.
Okay, that's fine then. Might be Sunil on the mute. Okay, so okay, one more very important tool is called container and container orchestration. Okay, now for containers, actually, there is a lot of different tools are available, but we are going to cover Docker actually. Docker is very famous tool which is available, that we will be covering here. Now, for container orchestration, what container orchestration means? Container orchestration means how you can orchestrate your container, right? When I'm saying orchestrate means how you can make sure that whenever there is a need, the container number of containers can be increased. Whenever there is a need, the number of container can be decreased. All those things. How you are going to cover that? How you are going to manage it? That's called a container orchestration tool actually. Okay. So for this thing, Kubernetes is actually a container orchestration tool. Okay. So Kubernetes we are going to cover at the same time. ECS, Elastic Container Service, right? Both will be covering. So these are the tools that we are going to cover today. Okay, so hopefully now these things are very clear for you. What all the toolings are there, how we are going to, different tools, which tool sits at what place, right? We'll cover one by one. Any question, Adel, from here? Might be Sunil, if Sunil also got joined.
No.
Okay. So that's all from the day 2 documentation. Now I'll start on the day 3. So we'll start discussing. I'll share these things, with all of you, Adel and other people as well. Okay. Whatever I'm noting down so that it will be helpful for you.
Okay.
Okay, now we'll jump on the day 3. So day 2 is totally completed. Ideally, we are on the day 3 actually, but we are a bit behind. Okay, so I'll start discussing about the Docker. Let me just brief few things before we start installing Docker and see how exactly they work actually. Okay, so few things that you should understand what exactly the Docker. So first thing that you should understand, Docker basically provides you the containers. Okay, Docker is the company name. Okay, Docker is the company name which which that company is providing you the infrastructure for the containers, where you can create the containers actually. Using their software, you can create your containers. Okay, so same thing we are going to discuss here. So I'll just give you a brief idea what exactly the containers is. Okay, then I'll try to jump on the practical system. We'll try to install the a platform where we can install Docker. Okay, and then we'll see how the Docker works and all those things. We'll try all those things. Okay, so the very first thing is, let's jump on some introduction. What exactly the Docker is? Okay, so as I said, Docker is a company that's called Docker Inc. Okay, and basically the Docker was being Docker is an open source solution actually. Okay, when I'm saying open source solution, it means that open source means the source code is already available. Anybody can fork it Anybody can fork it and start utilizing. Okay, so initially the Docker container is named as a movie. Okay, movie was the initial name actually. Movie was the initial name, and using that movie actually, the Docker have been created. So basically, anybody like you can claim, you can fork that one, that open source solution is available there on the GitHub. Anybody can fork that solution and they can start utilizing. So Docker is just giving you the open source form. That's why I was mentioning that why people are not going for the AWS. Think about that. If you're going for AWS containers in the container solution in any of AWS Azure, obviously they will be giving you some benefit, but there are charges also coming. Okay, the charges are also coming, but at the same time, when you are using these Docker containers or other open source solution, there is no single charge that you have to give, and you can customize. You can customize as per your understanding actually. Okay, so whatever is needed, what you have to do it, everything that you can control. Okay, there is no control from the anybody. But yeah, there is some risk will be also coming. When I'm saying risk means you have to make sure that the security is being tightened, right? All these things you have to take care. Okay. So the company based out in San Francisco, then found by Solomon Hykes. Some history is being given actually. So let's go through, and you can see it's not too much history. They have initially the name was .cloud. Initially the name was .cloud. Then they have rebranded actually. They got rebranding as a Docker. They have two editions. That's the enterprise edition and the community edition. So basically, most of the we are the 4 condition, whatever the free one we are utilizing, that's a community edition actually. Okay, so we don't have to worry about it mostly. And if you're going for enterprise edition, but on the real-time example, real-time scenario, like if I'll tell you my experience, I've not seen anybody utilizing plain containers, but containers are always being utilizing with some orchestration tool, like either it will be used with the ECS, Elastic Container Service, either it will be used with the Kubernetes actually. So means the baseline operating system, baseline container is a kind of virtual system, right? You're not getting a fault tolerance, you're not getting that load balancing thing. But if you're going with the orchestration tool, you are getting all these benefits. That's the reason people are the only base line containers are not used. I've not seen anywhere it is being used. Maybe somebody is using for testing purpose, etc. That's a different thing. But mostly people are using in orchestration. So we'll see how they are working in the orchestration. But before you go in orchestration, because the baseline is the container, so that's why we'll try to install Docker containers, we'll try to create some container, we'll try to connect them, because if you don't understand that baseline, you will not able to understand them into the orchestration as well, because that's the same containers are being utilized, right? So that's why understanding is important. That's the same thing we'll try to explore it here. Okay, so see, community edition and enterprise edition, both are available. For enterprise edition is not the free, but you have to some supports and etc is there. C edition is free, that we can utilize. Now you can see here, if it is a community edition, Docker is still giving support, but they are giving only for 4 months. But if it is a E, they will be giving you 12 months every time. Support will be available there. That's an open source project. I told you, right? It's a free. Okay. Now, why Docker, right? So for that things, you have to understand the difference between containers and virtual machines. Now, remember, this is a very common question in by the interviewers. Most of the interviewer will ask you that what is the difference between container and VMs. Okay, so I'll spend some time here so that you can understand properly what is the difference. So VMs we are creating, virtual machines is nothing but whatever the servers we are creating in AWS, actually they are virtual machines. When I'm saying EC2 or any Linux, Windows machines that we are creating, right? All those are as a virtual machine, right? So that feature, somewhat that feature is available in that virtual machines as well. That if let's suppose I need a different application, right? Different application running on a different operating system. Some are running on the Windows, some are running on Ubuntu, some wants to run on the Mac OS. So how I can get these requirements fulfilled? Okay, so in virtual machine as well, you can fulfill that. Similar thing can be fulfilled in a containers as well. But we'll see why exactly the container got needed. Why, if we have the concept of virtual machine, let it be running, right? Why exactly it's needed. So let's jump. Let me just show you one thing. Here are the containers here. Now, if you see this picture, so this is the physical server, right? This is the physical server. Okay. Now on this physical server, you know that I think yesterday the virtualization I have discussed already, right? So there is one. Let's suppose there can be it's not necessary that the only one physical server will be there. There can be multiple. Like let's suppose there is a multiple. One. Let's suppose this one is 2 and this one is 3. Okay. Now think about let's suppose there is a 3 physical servers are there. Okay. Baseline servers are there. Now I have already discussed with you that if I need virtual machines, right? How exactly that virtual machine will work? I will install a hypervisor software. I will install a hypervisor software on these machines. I will just make sure that there is a communication between them is established. I'll just show you. Okay, we need a two-way communication between them. Okay, so let's suppose both are interconnected, all three are interconnected. Okay, what I'll do, I will just install a hypervisor software on above of these machines. Okay, so let's me tell you here, one way connection is needed. Okay, let's suppose container platform like this. Okay. Okay, here one way connection is needed. Okay, so there is a three physical machines, right? On these three physical machines, I have installed hypervisor software, right? Now, using this hypervisor software, remember I told you that if I use this hypervisor software, if we have three different machines, physical servers, let's suppose they are with 1 GB RAM plus 10 GB disk. Okay, let's understood. 1 GB RAM plus 10 GB of disk is available there. Okay, all. Okay, here as well. Okay, so what will happen if this is available, and if I have installed the hypervisor software, what will happen? I'm available with 3 GB of RAM and 30 GB of disk, right? This is how your virtualization concept works. Okay, now on top of these this hypervisor playground, I can create some virtual machines, correct? Okay, so let's see. All can be created. Okay, so okay, so all using this 33 GB of RAM and 30 GB of disk. These machines are different virtual machines. A Linux machine, a CentOS, a EC2, a Red Hat, right? All different virtual machine can be created. This was a concept of your virtual machine, right? That if I need a multiple operating system, if I want to use the cohesive environment, like the total environment which is available on the physical machines, these benefit was there already in the virtual machines, right? Now what triggers you to go for the Dockers? Now, what was the challenge? The challenge was, if it is a virtual machine, what will happen if, let's suppose, I'm going for the Linux machine, right? So for Linux, actually, I need all the binaries. It's the entire operating system actually. Okay, so remember, whenever I'm installing, let's suppose Windows I'm installing, right? If you see my machine, if I'll go here, C drive, Windows, right? So these are I cannot change all these things, right? So there is a data, there is a, not data, this Windows folders, right? Windows folder and the program file and etc. These are by default coming with my operating system. It means some libraries are there which is needed actually. I cannot avoid that, right? This is mandatory thing. The same way, if I'm installing any operating system, that's a mandatory thing which is coming with the operating system. So that's library things are coming with the operating system, and that's the reason actually they used to be very heavy. Okay, so now what happened? We got a new solution. Which is called Docker platform actually. Okay, Docker containers. Okay, what Docker containers are doing? Okay, the Docker containers will use, let's suppose I'll just use any one EC2 machine. Let's suppose I'm just using one EC2 machine on one EC2 machine. What I'll do, I will install the Docker containers. Okay, and what Docker container is going to do for me? Docker container will create the similar kind of the same VMs, CentOS and all CentOS, Red Hat, and a Windows, not Windows actually, but other platform VMs can be, other platform containers can be created, and they will be very lightweight. Now in containers, we are providing only files which is core or bare minimum files we are providing. Now let's suppose in a Linux machine, okay, let's suppose I have to run Python, right, in Linux machine. Now, okay, that's fine. Whatever binary files is needed to run the Python, That is mandatory, that I'll install. I cannot avoid, right? What about rest, right? Rest of the files are also coming, which I don't need. I just need my, I don't care, right? Whether, my Linux is running or not. What I care is that my Python should be running. The application, the core application which I am looking for, that application should be running. I don't mind for the other things. Correct? So that's the reason actually in the containers have created a more bare minimum machines, which is only being created, which, which application you're going to use. Only those files will be there. It's very lightweight. Okay. And one virtual machine also can be broken further. Now, in a simple layman terms as well, if you try to understand, so you can see here the physical machines on layer of physical machine hypervisor, and we have broken in a different virtual machines. Now that virtual machine further can be broken into the containers. So on one virtual machine, I can run multiple containers actually. Okay, that's how this container concept works actually. Okay, so one EC2, multiple containers. Now, if you see here, the virtual machine I have already briefed you. Then container. Container is exactly what you might expect it to be based on the general definition of the word. It is entirely isolated set of packages, library, or application that are completely independent from its surroundings, right? It's a machine actually. It's operating system itself, but only those things which is exactly you need. We are not going to create any other things. We are not going to give any other things. So if I'm saying, okay, this container is for Python, so only Python will be run. Nothing else that you can utilize there. Okay, so understanding of containers and virtual machines are very important. So just go through it many times, the definition. There are people, the questions are mainly being asked actually. Okay, any questions here, Sunil or Adel?
No questions.
No, I'm good. Are we going to like run Dockers as part of the?
Yes. I'm just starting it. I'll
Okay,
just
excellent.
start
Okay, cool. That sounds good.
Okay, now two concept. I'll just brief you. Then we'll jump onto the installation. Right? Images and containers. Just understand two things. It's all built around those only two things. Okay, images and containers. Okay, now the way I'm saying, if you see in AWS, okay, so whenever I'm going for EC2 creation, okay, if I launch instance, I'm not going to launch it. I'll just show you. So if I'm going to launch instance, it's saying AMI, machine image, Amazon machine image. Just choose one machine image. What exactly this machine image is? Machine image is nothing but, it's a kind of snapshot at particular time. Okay, any particular snapshot at one time, at one point of time, the same snapshot you are using multiple time to create computers. Okay, similar way there is a concept. Similar way there is a concept of images and contain images and the containers as well. So you can consider as a container as a EC2 machine and image as a AMI, Amazon machine image. The way we are using Amazon machine image, and on top of Amazon machine image we are creating on top of Amazon machine image, we are creating EC2 instance, right? Same way, there is a concept of container images, okay, Docker images, and we can use Docker image, and then we can use the Docker containers. We can use the same Docker image and build our Docker containers. That's how it works actually. So Docker image and container, two different things are there. Just be very sure. Okay, you can see here the Docker images use images to create an instance of a container compromise comprised of multiple layers, build time construct, build from the instructions. Okay, so we'll tell you everything, what exactly the meaning of build from the instructions, then build time construct, how exactly it is being built, right? All those things I'm going to brief you. For now, just understand image is nothing but a snapshot of a particular time. Okay, similar image you are going to use multiple different places and different times for creation of containers. Containers. So containers use that image action. Okay, and containers is nothing but it's kind of machine itself. Containers is nothing but it's kind of machine itself. The way machine you are running, same way you can run the container section. Okay, so for that purpose, basically it's good that if we do it, we'll understand it properly. So what we are going to do it, open this lab section, and there is a lab for Docker installation, the very first one. Open this one, we'll try to do it. This is the same one, we are going to do it. Okay, so I think it's almost 1 hour. So let's have a break of this hour, and then we'll come and then we'll do the installation so that we'll not stop in the mid. Okay.
Yeah.
Thank you.
Okay.
I'm back, guys. Let me know once you are here.
Hi Rahul, I'm back.
Okay.
I'm back.
Thanks, Arul.
Hi.
Okay, so let's start. Okay, so as I said, we are going to install our AWS, machine. We are going to start our AWS machine. On that AWS machine, we'll try to create our Docker installation. Okay, so setting up the machine, then setting up the Docker. That's all we are trying to do it from here. So now again, it's up to you, because other people are anyway, they are going to refer the recording, so they can refer the recording and do it. And if both of you are there, if you wants to follow with me, you're very well welcome. Even though if you want to do it later point of time, that's fine. I'll just show you. Okay, I'll keep preparing that system, and I'll keep noting down as well those steps if there is any changes or something, so you'll be aware. Okay, so the very first thing what we need a Red Hat 8 machine. Okay, and that should be on AWS EC2 machine that we need. Okay, so let's do it. Very first thing, okay, let's create a EC2 machine, Red Hat EC2 machine with 64-bit installation. Okay, so let me start from very much basics. Okay, so I'll create an EC2 machine. I think EC2 creation, it's everybody is already doing it. Okay, now I'll just create one EC2 machine. If you are already running, I don't have any issue. You can just use the same one, but make sure it is running on Docker or Red Hat 8. Otherwise, you'll face trouble later point of time. I'll give name as a Docker. Okay, now I just said I need Red Hat, right? So I'll just choose the Red Hat. You can see Red Hat 8 by default is coming. If you're going for the the lower version, you have to browse and search it. So by default in the quick start, they have given as a Red Hat 8. So fine, I'll utilize the same machine. Yeah, and it's a free tier. It's available as well, free tier eligible as well, which exactly we are looking for, right? And remember, I said it should be 64-bit. Yeah, that's a 64-bit available. T2 micro is fine for now. We'll see later point of time if it is needed that we need to, make a higher config, that we will do. But right now, T2 micro is more than enough for our requirement. Okay, key pair you have to choose. So same key pair. Remember AWS 10. Keep on using everywhere. If anywhere Windows is needed, then I'll use the Windows. Only 2 keys needed. Remember, I've just created only 2 keys. So AWS 10 I'll be using. Okay, this one is very important, the network setting, right? So I'll choose my VPC. I'll choose the public subnet, and this one should be enabled. Okay, and then security group is also needed. So just choose the security group which is already created. AWS 10 is fine. Disk 10 GB is coming. I think more than enough. I don't need any other disk. Okay, I don't think anything else is needed. Just say launch instance. Let's give it another a minute so that it should be get created. Let's wait. It'll take, I think, another 1 minute. Let's complete it. Then we'll try to connect it. I think I should be able to connect it, but let's give. Okay, let's try to connect it. Still, it is initializing, but I think it should be good till now. But let's try it out. Okay, remember how I can connect it? I need to connect it via putty, right? So putty is already there in the same folder where I'm currently working. Here you go. Okay, so I'll say IP address, similar way. In SSH, you have to come, auth, you have to choose your key. That's AWS 10, yeah. And it will ask me the username, which is EC2-user. Okay, so this my machine is got set up now. Now I'll start focusing. Okay, implementation. So there is a two requirement. So very first requirement is you have to do the sudo. That's fine. You just have to make sure you are root, and we have to update the packages. Actually, that's very important. If you don't update it, later point of time you'll be in trouble. You'll be in trouble to install it actually. So try updating everything. If there are some updates, fine. It depends, like the region you are working. Sometime you will be having some updates. Sometime you'll not be having. But then also run this DNF update command and reboot it. So if there is any outstanding package will be there, that will be get updated. Okay. So let me just make a big change font so that it is properly. Okay. So the very first thing I'll doing sudo su. Okay. The command is DNF update and then reboot, right? So I'll just run DNF update.
What does it do, the DNF update?
Yeah, I said, right? If there is any packages are there which is not updated, what it will do, it will just go on Red Hat website, download those packages and get it updated. Okay, this thing will be different because let's suppose I'm using the Mumbai region, right? If you're using UK or US region, it might be differ bit, but doesn't matter for you. You don't have to count actually what all the things is going to be updated or not. Like this time it is saying total download is 154 MB, right? This much file is going to be downloaded, and if I'll say yes, it will just download and update everything. Clear, Sunil?
Sorry, I was on mute. Yes, yes, I'm clear and I'm.
Okay, so I said yes. Okay, and if I'll run the similar command again, ideally there should not be any package to be updated. It will say you that there is no package to be updated because all the packages have been already updated.
This is kind of like the Windows update we do on our.
Yeah, that's the same Windows update. Earlier, actually, the name was Yum update. Yum used to be in Linux. We used to use the Yum. Now it's got changed. Now we are calling it as a DNF update. Actually. It's a kind of Windows update itself. Mobile update, release, Android updates are coming, right? So you're scanning what updates are available. Okay, these much updates are available. Let's go and install it. It is still doing the installation. Let it complete. If you are doing with me, it will take for you as well some time because there are some packages are there that it will try to install in the backend. That's why it used to take some time at this point of time. Yep, that's done. Okay, now just for your confirmation, if I run the command, the similar command again, it will run the scan again. Okay, and it's saying all the dependencies is resolved, nothing to do, that's complete. Yeah, it means all the installation is done.
Yeah.
Okay, now I'll just reboot it so everything get affected. It will take another 1 or 2 minutes. Let's wait. You don't have to close the window. If you restart from top, it will be get connected again because IP is not going to change. So just wait for another minute. So from here itself, we can connect it. Okay, if you top here, go there and say restart session. Okay, it will ask me IP EC2 user again. Okay, I got connected. Do sudo su again so that you'll be root. Okay, that's it. So the prerequisite is done. Now package installation and everything is done now.
Yeah, I'm not able to connect again, so maybe I will start on the session.
No, just wait. It might be a restarting action.
It's kind of like hung on that root.
Okay, that's fine. Connect it from outside. Just close that one.
Okay,
Sometime it happened that.
Okay. And on the AWS, it is showing running right now. So let me start a new party session.
Yeah, just connect. It will be just restarting. It will not take more than 1 hour. Oh, sorry, more than 1 minute. I'm really sorry.
Yeah. No.
Okay. The next one is now we have to set up this repository action. We have to set up this repository. Okay. Once because if we want to install Docker, we need this repository. Without this repository, the Docker cannot be installed. Basically, we are saying that from where Docker need to be downloaded by this command. Okay. So I'll just run this command. Let me just clear it so that you'll be able to see. Okay. So we'll run this command. Okay, repo got added. And if I run this first command, dnf list docker c, ideally I should be able to see the Docker. If I'm not able to see, if you're not able to see the Docker, then it means there is some problem. Now you can see here that package is available, right? If this repository is not there, and I'm trying to search for the Docker CE, it will show that there is no package available. If you want, I can show you. Okay, so basically where exactly this repository is getting added. This repository is getting added in cd/etc/yum.repos.d. I'll show you. cd/etc yum.repos.d. You can see here, this is the Docker C, right? I'll copy this one as well.
I'm not able to go back to my machine for some reason.
Try connecting it. If not, I'll help you.
Let me make sure I am using the right keys. So and then you log in as AWS user, right?
Yes.
AWS hyphen user, right? AWS.
That's correct. No, it's a EC2 hyphen user.
Oh, EC2 hyphen user. Okay, no, I'm fine now. Yeah, it's working now.
It's good.
Yeah. I was logging as AWS user and it logged me in and then it was logging me out. Do you know what that AWS user is?
No, it's not AWS user. It's a EC2 user, Sunil.
Yeah. So if you type login as like AWS user, I was like,
then you'll not be able to log in.
But anyway, it's fine. So let's continue. It was logging me in and then it says we are logged out or something. Okay. But we are there.
So it will give you error, right? Because the user is not present on the server.
Yeah, there is no user like AWS, right?
Yep.
So you want me to sudo to root now, right? Sorry,
Yep.
Okay. Sudo sq dash, okay. And now I'm a root user. And then which directory are we in? If you do pwd.
Okay, so I was showing you that if you run this command docker list docker c, right, I'm able to see these packages, this package docker c region behind it, because I've just added a docker repository action. Okay, so I was showing that if I'll come here on this location /etc/yum.repos.d, you don't have to worry about it. I'm just showing you. You just have to run this command, the first one, so that the
can you provide that command in the chat window or maybe it's in the document, right?
Yeah, the document is there already for this one, Sunil. If you want,
hold on. Let me make sure I'm on the right document. So this document is the, what is the document? We are following the document.
It's a hands-on lab Docker installation.
Hands-on lab base C. Lab. I had to work on something during the session and I missed some of it, like in the previous session. But I'm with you. So we are on the section 5.2.
That's correct. Yep.
And then
so you can see this is the command, right? DNF config manager --add -repo, right?
Yeah.
So if you run this command, and after that, if you run this command docker dnf list docker ce, you'll be able to see this package.
When I ran the previous command, right, it gave me a message unable to read consumer identity. This system is not registered with an entertainment server. You can use subscription manager to register. Is that the message you got also? If I can see your term.
No. Okay, so that might be you have used some different. Okay, yum update. The DNF update did work, Sunil.
The DNF update did work. The before we did the reboot, right? I did the DNF update and that worked. And right now this.
Okay, just show. Can you just show me?
Yeah, sure. I can share my screen quickly.
Yeah. And it'll just be with us. Might be other people also face such kind of issue. So it's important to fix the issue. Yeah.
Do you see my screen?
No, that's not error, no, Sunil. That's got added. You can see the last line, right? Adding repos, repo from the, so repo got added.
Oh, okay. Okay. So we are good, right? Okay.
Yeah, we'll be.
So this is not a message you need to worry about, right?
No, that's not. Don't worry about
Let me- Thank
it.
you.
Okay. So I was showing that if you run the second command, dnf list docker c, so you'll be able to see the package there, right? Okay, this is the docker c package is available. Now I was trying to say that why we are able to see because we have installed that repository actually. If we don't have that repository, then what will happen? Okay, now how I can see where exactly my repository is. So this is the location /etc/cm.repos.d. This is the place where all the repos are being installed. So docker c.repo. This one got installed here, right? So you don't have to follow this one, Sunil.
Okay.
And Adel. So this one I'm just showing you for your understanding how the repository is getting added and how exactly that works actually. Okay. So like let's suppose I'll just remove this repository. Okay, then we'll see whether rm-rf. Okay, now we'll try to run that dnf list docker again, and we should not be able to error. There is no package available, right? It means repository is not there. Okay, so let me install the repository again. The same command which I have given.
Yeah.
dnf
Okay.
config.
I'm getting it now. Yeah. Okay. Got it.
Okay, now if I'll install it, it's got added. Now you can see here the file got added again, right? docker-c.repo. And if I'll run the command docker list now, I should be able to see the package there. Here you go. Right? So it means that why we are adding that repository. If we are not adding that repository, we will not be able to install Docker. So for Docker installation, we are adding that repository. That's extra. Basically, repository is nothing but we are telling Linux that there is a website of Docker. There you have to download and install the Docker. Simple. Because Red Hat don't know, right? The Linux don't know where exactly you have your repository. From where it need to, because it's not a Linux product. Docker is the external product, right? So let's follow the document again now. So for installation, this is the command. Simply just run it, dnf install. dnf install docker ce -no base -y. It will take some time to install it. Yep, installation is completed now. Okay, now we have to start the service. So I'll run this command, start the service. Okay, and enable it as well. Okay, now if all good, if I'll run this command docker info, ideally I should be able to create, I should be able to get all the information about Docker, what kernel version we are using, what Docker version, what all the information, etc., etc. We should be able to get it. If you are getting this output, then it means that your installation is good. You're good to go.
Almost there.
Yeah.
If I type Docker info and it tells me what it is, right? Then we are good. Yeah, I'm getting it. I'm getting the same output as yours.
I'm installing Docker now, so it's gonna take in a few minutes.
Okay. Yeah. Just complete both of you. Let me know, then we'll proceed further.
Sure.
So basically, that's the first part, right? There is a two part we have. Okay. So one is, if I'll talk about Docker installation, right? Meanwhile, you guys are completing, so I'm just utilizing that time so that I can brief you. So in Docker installation, there is a two different things. One is Docker installation that we just did. There is another component called Docker Compose actually. Docker Compose installation. Okay, you might not be aware what exactly Docker Compose is, so don't worry about it for now. Just focus on the installation. If the installation is done, we are going to utilize the Docker Compose in the coming, section. Okay, so we'll focus on the Docker Compose installation. Let me know once Docker installation is done for both of you.
I just did the Docker info and I saw those information there.
That's good. Then
are we doing the hello world as well? Docker one.
No, hello world. If you want, you can do it, but don't worry about it. I'll show you anyway. This one is just to testing whether your Docker is running. So Docker info, if you're getting output, it means that's good. I'm just starting the, after this, I'm going to start the Docker details. So I'll run all these commands. Don't worry.
Okay, sounds good. All right.
What about you, Sunil?
It's working for me. Yeah, up to the hello world. Yeah.
Okay, that's fine. So hello world is nothing but, it's a first container. So anyway, I'll show you how you can create and what exactly it is doing. So right now you'll not understand actually. If you run it, you'll not understand what exactly it is doing. So I'll show you later.
Maybe if you can do a quick refresh on container versus virtual machine, because it looks like a virtual machine to me, but it is not.
Yes,
so.
yes.
Yeah.
I'll brief you again.
Yeah.
Just complete the installation, Docker Compose
Okay.
as well. So
Okay.
then I'll brief.
Okay,
you.
so continue with that section 6, right? Okay.
Yep. So just install these two packages with the curl and wget. So curl is already, it might be giving to you as well, but then nothing to do. It means it might be already there. So don't worry. The other one is the wget. If it is already installed for you as well, so no worries. If it is not installed, just say yes and install it. Yeah. So wget also got installed. Okay. Now next one is I'm going to download this Docker Compose actually. Okay, make sure you're downloading from the this way. Just copy that entire command, leave that has thing, remove that has, and just copy and paste. Basically, this is the file which is already available on the Docker repository. I'm just downloading it, okay, and I'll run it. So let's download it. The very first, the second number command, which is wget, starting with the wget, yeah. Okay, it should be downloaded.
This is the HTTP 302, right? So do we have like a wrong server name?
Which one?
wget, right?
Oh, that's fine. That's the server is
It's
fine,
fine.
right?
Okay, so it did connect to the GitHub, but then it says HTTP request sent, awaiting response and CO2 found. Yeah, no, it all looks good. Yeah, okay, that's good. Yeah,
Downloaded, right?
yeah, I did. Yeah.
Hmm. Okay. So that's fine. Now give some permission to it. That's it. And run this command.
Hold on, which directory are you in? You are in the
I because I logged
QDB?
into the repos, right? So doesn't matter wherever you are, because it's just we are redirecting that output somewhere else. So don't worry about it. Wherever
No,
you are, just
the CH mode, right? It has to be in a.
so
Okay, that's good.
basically because you have downloaded, right? So wherever you are stand currently, whatever the directory, it will be get downloaded there itself. And if you run the
Okay,
CS mode, obviously at the same place it got downloaded, right? So you
got it,
don't have
got
to
it.
give the full permission, full
Okay,
path actually.
perfect. Yeah. Okay. Mhm.
Okay, then I'll just move this one. Okay, so sudo mv, move it to this particular location. USR local bin and Docker compose.
Okay.
Now, if you run this command, Docker compose version, if you're getting output, then it means all good. You're getting this means the installation is good. And if you're getting error, then it means that the installation is not completed.
Yes, working for me. Yes.
For you as well, Adele?
Yes, it is working. Yeah.
Okay. Then next one is, this is the completion, bash completion, even though if it is just run these two commands as well. If working, fine. Even though if it is not working, don't worry. Sudo call. Basically, it's nothing but, we are making sure that the completion, auto completion, it's working. So just run this command. Yeah, that's fine. Just copy and paste. Basically, it's just a completion. It will just update your source profile so that whenever you run the Docker compose from your, like here, okay, this way it should start working for you. So you don't have to give that full path. Okay, it will be in your source profile for always. Okay, so if I run docker-compose version, I should be getting output. That's it. Yeah, if you're getting it, it means all good. Okay, so installation is done. Uninstallation is not needed. If it is needed somewhere, then we'll go and do it. But for now, it's not needed. Okay, now we'll focus on, I'll just brief again that containers and virtual machine. But let me just open another document, the second document. Just open the second document, which is hands-on lab on Docker. So we are going to explore a lot of things in Docker now. Okay, so before that, let me just brief you one more time as Sunil have requested. Virtual machine and containers. So as I said, containers are also similar kind of virtual machines, the way virtual machines are working. Only difference is like, in virtual machine actually, it is coming with all the libraries and windows and other files, right? Whatever the mandatory, whatever the files are there, every libraries and every files are coming with the operating system. But if you are going with containers, only mandatory, or you can say only bare minimum requirements are coming. Okay, which is actually needed. We are not like, as I said, if I'm going to run a container for Python, so only Python related operating system will be coming. sorry, only Python related binaries will be coming. Okay, now I'll try to brief you again. So basically, so the way I said, right? So in when you're running this instances here in AWS, you're running based on some images, right? You're picking some images. So images is nothing but, it's a snapshot at particular time that AWS have taken a snapshot and kept it for you. Right now, remember why I said that the update is needed, because think about, let's suppose 6 months back, AWS have taken a snapshot and given to us. Okay, boss, whenever you want to create EC2 machine, create it. But in last 6 months, Red Hat might have given a lot of updates, right? Those updates are missing because it's a snapshot at particular time. So that's why whenever we are creating EC2 machine from that image, we are updating so that whatever the latest image is there, whatever the latest packages are there, that will be get updated, right? So now basically there is a particular image. Using that image, I'm creating my machine operating system, right? Where I can log in and work. Same way in the containers, there is as well image and container feature is there, where image is the base snapshot which we are using to create machines, containers. Containers are a smaller form of your virtual machine, you can say. So in virtual machine, we are giving all the operating system file, all the binaries, everything we are giving. But here only bare minimum. Like, let's suppose I'm saying on this Windows machine, what all the application I'm running. So I'll show you taskbar, task manager. Now you can see here what all the application I'm running. I'm running Windows, Microsoft Word, Zoom meeting, and let's suppose I'll say I'll use this machine only for the Zoom meeting. I don't need anything else, right? But if you go in Windows folder of this machine, there is a lot of, the files, folders, file, and all those things are coming, right? In Windows, a lot of files are there. Okay, I don't need it. I will say to Windows, boss, I just need Zoom. You tell me what is mandatory for Zoom to be running. I don't care that the Windows is running or not running. I just need.
So containers is just the package you need to run your applications, right?
That's correct. Only that particular application, nothing else.
Yeah, your particular
whatever is needed for that application, that package will be coming. Simple.
Okay, and
So,
he uses the operating system, the VM operating system, right? Or
yeah, you can now. That's also a good question, actually, Adel. So you can do that installation at any place. That's a flexibility that Docker is giving to you. So Docker installation can be done on the virtual machine. Docker installation can be done on the physical machine, and there is a Docker desktop app is also available. Well, I would suggest you guys can give a try that one.
All right. Okay. Thank you.
Okay. So, Sunil, you're clear?
Yes, that's good. Thank you. Yeah, it's a bare minimum operating system for
bare minimum. Only that
running.
application. If I'm saying I'm creating container for my Python, only that whatever needed for Python to be running, that only is going to be created. Nothing else.
Right. So it doesn't need any other libraries.
Nothing, right? That's what I'm saying. If let's suppose on my Windows machine, I just want to run this Zoom, right?
Yeah.
Why the hell I need all the this much big all these boot containers, courses, debug, etc.
Right.
I don't need it, right? So that Windows can tell me what they need. They can tell me that okay, this tracing folder needed, that twin is needed, VSS is needed for Zoom to be running. Fine. I need my Zoom to be running. Whatever needed, you tell me and give it to me. I'll make sure that running.
Right.
Okay. So now let's run the very first one, the Docker hello world, right? So ideally IT is starting with always a hello world. Yeah. So we'll try to run that hello world first, and we'll see how what hello world is doing. Okay. So before that, let's run two commands, which is you're going to utilize everywhere. So the first command is Docker images. Okay. This command is responsible for Docker utilization. Okay, so the very first one, this one is important. This one to list images. Okay, that's remember Docker is all built around two things, only two things: images, containers, images, containers, images, containers. Right? Images is a snapshot. That snapshot you are using will create your container. Container, always think about the virtual machine, a kind of virtual machine, right? So I'm using that image. I'll create containers. Now, one more question you can arrive in your mind. Okay, in case of AWS, when I'm going creating EC2 instance, like let's suppose I'm going to launch an instance, right? So here images AWS is giving to me. AWS is saying, boss, these all images are there. You can pick anyone, right? What about Docker? How the images is coming? Okay, so for Docker, they also have a repository that's called Docker Hub, hub.docker.com. Docker.com. Okay, so here, if you come here, there is a lot of things are available. Okay, just make sure you logged in. It's a simple, the way you are registering with your email address and something, the same way you can register here. I'll just give you. So hub.docker.com. Okay. So that's fine. It's not needed immediately, but I'll tell you when to register. Okay. So let's run. Okay. Anyway, otherwise, it's better that you can get registered here, because then I'll correlate with you from where exactly it is getting downloaded and how it is working. So just get registered here.
Okay.
It's a simple register yourself, email address. I think nothing, ID card, nothing it will ask. I also need to check my email for, I don't think I remember the password. Just give me a moment. Let me stop share. I'll search my password. You get registered till now, till that time. I'm trying to search my password.
I am registered.
Thanks, Adel. I got my password as well.
Continue free or
Yeah, that's a free only. Don't need to go.
personal free? Okay. All right.
Yep. Sunil, you're good?
I apparently I have an account and I don't have the password, so I'm doing like a forgot password thing.
I did the same thing. Okay, so that's fine. Nothing, nothing special for now from there. I just want to show you few things. Like if I search for hello world, right? Okay, now if you see here, hello world, right? So basically here for everything there is images are available for each thing. You just tell me what application you need. Okay, any application you check, you will check that, and that will be available. Java, Node.js, or Tomcat, everything is available. You don't have to go for installation one by one. Whatever the package is coming in your mind, it will be available here for sure. Okay, they have built in that way. So like we'll start with our hello world. Then we'll proceed further. Now you can see here hello world is nothing. Okay, so now let's suppose on Linux machine, right? This is my Linux machine. If I'll say echo hello world, okay, I will be printed as a hello world output, right? So the image, this Docker image, hello world image is nothing. It's not doing anything. It will just print you a hello world, simple. But good thing is this hello world, when I'm running this hello world, it's being run on my local machine. Okay, when I'll run the container of hello world, this command will go in a container and run it. I'll show you how. Okay, so if you run the Docker images, again, there should nothing running, right? And there is one more command, Docker ps command. This will show you any running container on your system. Okay, and if you can run the Docker ps-a, it will show you all the container which got run and shut down as well, right? So there is nothing, because right now we have not done anything, right? So let's try doing it our first container, which is the Docker run. Okay, so what I'm going to do it, okay, let's run this Docker, Docker run hello world. That's the first one, right? Which I have given you in that earlier document. Okay, so if I run Docker run hello world, what it is doing, it's saying unable to find the image locally. Means on local there is image is not available. It will just go to the Docker and it will source this image information, and it is just printing all these information. Okay, now from where all these information is coming, it's coming from image action, the image which is already built, which AWS, which Docker have built it. Now if you come here on this Docker image, you can see here the example output what we are supposed to get, right? The similar output we are getting, hello from the Docker and all blah blah blah, right? The similar, because somebody have put all these lines and put into that image. So image is nothing, it's not doing anything, it's just printing you a hello world, nothing else, right? But there are few things must be got changed. Now if I run the same command, which is Docker images, which to see what images are there. Now you can see here there is an image hello world, right? So it got downloaded, run it, okay, run it as a container and shut down as well. So if I run the Docker run only command, Docker run basically will create a container from the image. If image is locally available, it will not download. But if image is not available locally, it will go and download, right? I'll just, so that's a Docker image for list the image. And then second command is Docker PS for any running container. Okay. Next command is Docker run command, right? So Docker run will run the container. Run the container. Okay. This is the difference. Okay. So if you run the Docker run command, it will run the container from image. Okay. So here it runs the same thing. It just download the Docker image. Whatever inside Docker image was there, it just run and print out to me.
So Hello World is an application, right?
Yeah, it's a simple application, 13 KB application somebody have prepared.
Right.
What inside that application is there? Nothing. It will just print you this information. That's it.
Right.
Hello from Docker Word, something, say somebody have put it. And
right.
you know, that printing, that it will just print you in front of you. A kind of, you know, a small application somebody have printed. Okay, whenever you run this container, this information will be populated in front of you. Simple.
Can you like get a list of like what are the other applications available? Or,
there are, I cannot give, because you know, huge number
sure,
of, you know, you just search, you
and there will
whatever,
be like
you know,
tons of application, right? Okay.
everything is available. If you go and explore, there is a, you know, you can see there is no number, there is no
Yeah. Long list. Yeah, got it. Okay.
not this one actually.
Okay.
There is a long list actually.
Yeah, I'll
See here,
download
right?
other things after the and then see how it goes. Yeah. Okay. Got it.
So okay, now there is a big difference. I just want to show you, if I run this command, this is the first one, which you know, 5.0, that's Docker run Ubuntu /bin/echo hello world. Okay, I'll just show you what exactly the difference here. Okay, so now what I said in this document, I said if you run the Docker run command, it will run the container from image, right? So if I come here, so Docker run, it means it will run the container from image. What image I'm going to choose? So Ubuntu is the image here. Okay, it means that okay, what is my base machine? Remember base machine, which I have where I'm currently running. That's something etc/Red Hat release. That's a Red Hat 8.0, right? Because remember, we have initially installed Red Hat 8, right? So my current machine, the base machine is running on Red Hat 8. Now let's suppose I have an application which will not run on Red Hat. I want to run it on some different operating system. Let's suppose Ubuntu. What is the solution? So container could be a best solution for you. So now if I run this command, what this will do, this one basically run the Ubuntu container, and inside Ubuntu container, it will run this command. Hello world, inside, going inside and then run. You got my point?
Yeah.
So basically, if you run outside, simple here. So it will just print you hello world, right? Simple hello world it's printing, but I don't want to print on my local machine. I want this hello world to be printed on Ubuntu. I'm just giving you example, right? So let's suppose I have some kind of application which need to be run on Ubuntu only. Okay, so what is the solution? Either you can create another instance, right? In AWS, go and create another instance and do all these things. But the best solution is a container, running a container. So let's run this and see what's happening. So if I run, see, one more thing I would like to show you. if you see here, Docker images, there is only one repository is there, right? Hello world. Now I'm going to run another image, which is Ubuntu. So what it will do, it will download a Ubuntu image for me and then run this command actually. So let's run it. See, it's saying unable to find image locally. So it will just download it. Okay. And printed hello world. Now remember, this print of hello world didn't came from my local machine. It came from the Ubuntu actually. You want to still sure that I'm 100% sure or not? Okay, what I'll do, I will change the command. Now let's run /bin/bash, and let's suppose I will run cat /etc/star release. Or maybe just one uname A. I'm trying to show you one thing. Bin bash, right? Bin bash. And then host name. /bin/bash. And if I run host name, it's giving error. Cannot execute the binary file. Yes, it is coming. Okay, bin bash was not needed actually. So if I run the command cat /etc/star.release.
You misspelled ETC.
Something? Yeah.
You put
Oh,
ET.
yep.
There we go.
I was thinking why it's not working.
Yeah.
Okay, some path section we have to set up actually. Okay, that's fine. What I'm trying to show you here. So now let's suppose I'll just verify you the command which is running. Okay, so this if I'm running this command actually, so what exactly it is doing? Docker run. I'm running this Ubuntu container. Okay, and inside Ubuntu container, I want to run the hostname command. You know what hostname will give, right? So if let's suppose I'll run hostname here. So what it will give you? The entire host name, right? But if I want to run this host name inside my container, then I'll run that above command. Okay, this command. So what it is going? It is going creating my container and running this hostname command. So whatever the host name of that container, that is being printed here. You got the difference?
Yeah, so it really like, you're running a Red Hat, if you do like uname -a, right? If you see the operating system too, right? And
Yeah, it's a completely different. It's that's why, I was saying that when I'm running this first command, this hello world, actually, this hello world basically getting printed from your Ubuntu.
Yeah.
Okay. So if I'll run this hello world came from your Ubuntu machine, actually.
Yeah. But if you do like a PWD or LS or something,
Everything is, I'll show you as well. We can connect that machine. Well, we can right now what is happening when we run this command, docker run simply, what it will do, it will just go connect your container, and there is a feature in container. If you come out from the container will be stopped. Okay, so right now there must be not any single container will be running. If I run docker ps command, this is the command which will show you running container. See the difference, running container. There is no single container running. But if I run docker ps-a, it will show you a lot of containers. So you can see here, all the containers got started. The one I have just said, right? All have just tried to start it, get some output, and exited. So it means it has just given you whatever you need and stopped. So they build in a way that they will be just only up for a purpose. Right? You started, you did some work, so down. Simple.
So when you run this docker ps-a, right? That is running on your Red Hat, right?
That's correct. Yeah. It is showing me that whether I'm running any container, if the container is running here, I can see the containers. Okay, what inside container, that's a different thing. That's inside is completely different world. But as a base machine, I'm sitting here on this machine actually. So on this machine itself, all the containers are getting started. You can think about this base machine as a AWS management console. So from AWS management console, whatever EC2 machines are running, you can watch them and monitor them, right?
Yeah.
Now, what inside EC2 machine?
Yeah.
Yep.
Yeah. I was thinking out loud, like you said, Docker, when you run the command docker ps-a, it is like Docker itself is an operating system, and it is telling you that these are the things you ran in the last 10 minutes or ever since you started the machine, right? And if
no, that's a Docker command. Actually, it will just show you whether I'm running any container or not.
Correct.
Okay. Simple. So if I run a Docker PS, so any running containers are there or not. If it is already shut down, then it will not show you in Docker PS command. Then you have to run the Docker ps-a, then it will show you what is the current status, whether your machine got shut down, whether your machine is still running, what exactly status is.
So the status that says created, does it mean it's still running, or it is just different?
Which one?
The status is created. So most of the status are exit, right?
Yeah, all exited. There is no container running. Because if I run Docker PS,
the third from the top, right? The third from the top.
That one is also just created actually. It was not connected.
Okay.
There is no container is running.
Okay.
Okay, that was not connected actually. It was just created. That's why the exited step is not there.
Okay.
So anything, if you run the Docker PS, if there is any container which is already running, it will show you here.
Right. Got it. Yeah. So let's say, I'm working on an app, right? And let's say I want to make sure my app is working fine on Red Hat, but I also want to test the app on a Ubuntu. I can
Yep.
do that with this, right?
Yeah.
And I can keep that Ubuntu container running, right?
Yes. That's what I'm going to show you that one as
You're
well.
going to show that.
Let's
Got
suppose
it, okay.
I need Ubuntu. Okay.
Yeah, okay.
And let's suppose your maybe Ubuntu plus Java combination I'll search, right?
Right.
If your application is Java, I'll search something where Ubuntu and Java both is running. Okay.
Right.
So I'll create that kind of container where I can get the Java as well as the Ubuntu as well.
Hmm.
Right? In that way you can do. There are a lot of combinations are available, even though if there is no ready-made combination available, you can create. We'll show that one as well, how you can create your combination. I can create
Right.
that combination. There are a lot of flexibilities there. Okay. Any other questions, Sunil?
No, that's good. I got it. I got it.
Adel, anything from you?
No, I'm good. I got it.
Okay.
Thank you.
So we have just started. There are a lot of things need to be done. So it's almost more than 1 hour. I'll take last break. I'll try to get my last coffee and then we'll come back again. Yep.
Okay, 10 minutes.
Yep.
Okay, sounds good.
Okay, sounds good.
Hey guys, I'm back. So
Yeah, hey Rahul.
I'm back as well.
thank you. Let's try. Okay, let's try a few others things. Okay, so okay, so that was the first thing that we have run. Okay, now Docker images I have shown you. Okay, these things are okay. Now one very important, right? So earlier I've shown you that the whenever I'm running container and if I'm coming out, the container is getting shut down, right? Now the same thing we can change it actually. If we want to connect with the container, okay, let me just run one more session, duplicate session, then I'll show you. Okay, let's be sudo su hyphen. Right now, what will happen? Let me run the command the same way. Okay, same docker run, but I'll use -i-t ubuntu /bin/bash. Okay, now what exactly happened? Okay, so basically, see, whenever you run the command, right, this is the way actually run to any container. Docker run, and you have to give the image name, what image that I'm going to use. Okay, so I have used the Ubuntu, right? Now, -i-t, that's a interactive terminal. That's that's a flag is there in the Docker that you can utilize to connect it, to keep it connect. If I'm not using that -i-t, what will happen? The container will be get created, but it will be get terminated immediately because it will run just bin and bash and come out from it. But in this case, I'm saying just hold it. If I'm saying -i-t, it means it will hold it actually. Okay. Now you see here, I'm not on my base machine actually. I'm on my container currently. How I can verify? If I run cat/etc star release, okay, it will show me I'm running on Ubuntu 22, right? Remember, my base machine is Red Hat, right? So I'm currently running on my Ubuntu machine. Same way, now let's suppose I want to run some other OS. Okay, before coming on the other OS, let's verify it as well, whether it's a, so I'm saying my container is running, right? Let's run on the another session where the another session which is running. I'll just run the commands. Don't come out from that. And if you run the command docker ps, now you will see your container is running. Got it? And if you run docker ps-a, okay, it will show you up 2 minutes, right? The same machine is still running from 2 minutes.
Can I have that command again to start the container? Sorry.
Yeah, Docker run -it
-it. Okay, is it in the
Docker run -it Ubuntu /bin/bash. I've just sent on the everyone to the chat. So it will run and connect the container.
So that command runs and connects the container, right? That's the
Right. This one will run and connect the container as well.
Now I am no longer in the Red Hat Phoenix, but I am in
Yep.
the Ubuntu. Okay.
You are inside
Inside.
inside of your container.
Yes, I'm kind of in a virtual machine.
That's correct. Yeah. It's on Red Hat platform. Now let's suppose I want to create a multiple containers. Right? Different operating system. We can do that. Let's suppose I'm on another machine, on another terminal I've opened, right? Don't close that one. Let's suppose I want to run Docker run -it. What else I need? Let's suppose I want to run Java, right?
Java will not run because it will run and execute. So, but one question is, I am inside Docker in Ubuntu. How do I go back to the Red Hat now?
Just exit.
Just exit. So it will.
No. Just hold it and just open another terminal actually.
Oh, open another terminal.
If you right click here and say duplicate, it will open another session. Okay, so I'm running Java now. Here you go. I'm inside Java. Okay, now I'll just open one more duplicate session. So if I run now Docker ps-a, I should be able to get 2 machines there. Am I correct? Docker ps- sorry, not Docker ps-a. If I run Docker ps only, Docker ps, I should be having 2 containers, right? One is running for my Java, one for running for Ubuntu. Same way, multiple containers I can create. Multiple containers. I read some, CentOS, whatever I need. I'm not sure if there is something for Mac. Mac will be also, I think, will be available for sure.
When you run Java, right?
Yes, yes.
Okay. Now, if I run Docker, yes, right? It's telling me command not found.
No, don't run inside. Run another, because if you run inside, then obviously that will not work, right?
The Java is running, right? Okay.
Yeah, it's a Java. Now, if it's something you want to run with the Java, test it. Java will be running.
But Java needs an operating system. So what is that new operating system?
So baseline operating system will be there. /etc/ just run that command, it will show you. Release. It's a Debian.
It's a
cat /etc/ release star.
Okay. It's a Debian. Okay. That's like another Unix kind of thing. Okay.
Yeah, it's another Linux flavor actually, Debian. So basically, why Debian came? You got it right. So the Java which have been built, the official Java image that was built on a base of Debian, right? Now you can ask me, right, Rahul, I don't need this Java to be running on Debian, right? I need something else, some other combination, Ubuntu or some Red Hat combination, right? So either you can search there in the repository there, either you can update as well. That we'll talk about later.
Okay.
How we can update, how we can make sure that the uh, we can create our own image actually. Okay. Any trouble till now to understand? I'm happy to brief it again if anything is not clear.
No, I got it. So when last question, like when you say it's running Java, but Java itself doesn't run, right? So if you now it has a Java, it installed Java, right? So I can run Java, but it's not running Java. But got it.
No,
Now I
Java
have the
will be on a different place actually. If you run which Java, somewhere Java must be there. Here you go. So if you run their
that's the
command,
Java, right? And then you can run Java command, but then Java needs something to run, so it's not gonna run it.
yeah, by default it will not run. So anybody
Right.
who knows how to use the Java, you can utilize
Yeah,
Java.
you can write like a Java program, compile it, run it, do everything.
Run something Java version, simple.
Hmm.
Hyphen version, I believe. Yes, here you go. It's working. If you have something to compile and etc., you can use Java in this way.
Right, got it. Yeah.
Anything from you, Adel, before we move on?
No, we can move on.
Okay. So that's one thing. There is a few other things as well, how you can play around it. Okay, so let me just show you. So if I'm saying Docker PS, right? So you can see here, this is the container which have been created for the Java, right? Now let's suppose I want to stop it. So there is another way. Either you come out from the container, that will be stopped automatically. It will be exited. But if I want to stop it from here, okay, so there is a two-way. Either I can give this container ID, either I can give this container name. Both is fine. So Java stop container name. If I say this, I'm sorry, it's not Java. It's a Docker actually. Docker stop, and here you go. Now if you run Docker PS, ideally it should be gone. It's gone, right? Now what happened to the Java session? That one is also exited, right? So both thing is equal. Either you exit, either you stop. Both is fine. And if I want to run it again, so I'll do Docker start the same way again.
The names are something it picks on its own. Those names.
That's their repositories are there by default. Some random names have been picked up.
Okay, we can give something if you want, but it also default.
Yep, we'll see that one as well. How you can give the name. This one you cannot give container ID. You cannot tweak, but name can be tweaked. Okay, so now you can see here. I have just started the container again. What else I can show you? That's it, I think, from here. This one. Docker log you can check. So just keep doing all these things. You can, there is a lot of commands are there. Keep playing around it. You can check the logs. What logs means, it will show you what exactly happening. Okay. One important thing that we are going to do it is Docker networking. Okay. I think I prepared somewhere a diagram. It is still there. Docker networks. Okay, so what we are going to do it is okay, so we are going to create a networking section. We are going to check the networking section. I'll show you how you can check the networking and all those things. Okay, but in Docker networking, what total we are going to do it actually, because there are certain steps that we are going to follow. But before following those steps, you should be aware actually what all the steps that you are going to do it. Okay, so basically we will be creating a two different network. Okay, and these two different network will be attached to two different containers. Okay, and then we'll see whether they have been attached to the different applications or not, how we can attach it. So basically, if you see this diagram, right? So what we are going to do it, we will create two different network. One is the front end, another one is the internal localhost network. Okay, and let's suppose I'm sitting here as a user, web server. There is a web server. Okay, so think about, for example, let's suppose google.com is there, right? So I am here as a user, I am interacting with google.com. Okay, so there is two things needed. One is the Apache web server, front end application container, right? Which is the Apache, or it can be any Tomcat can be running, right? Front end, any front end. Let's suppose if I'm running this google.com, Google is nothing but it's a front end itself. Right? It's nothing but it's a front end. It's a front end which based on might be Apache or Tomcat. So if I want to know about it, there is something somewhere, I think F5 or something, some way you can get to know about this page. About this page. Apache, you can see, right? So it's running on Apache 2.0. Okay, so this Google is nothing but Google, whatever the front end is running, that's run based on some some Apache version. So now what we are going to do it in our practice, we will be creating two containers. One will be the application container, one will be the database container. Right now, when Google is running, so basically Google is the front end, right? But the data which you're fetching from here, if I'm searching something in the Google, there is a data in the backside, right? That's the internet. Sorry, that's a database actually. Some of the database must be there, like SQL, Oracle, something like that. Okay. Now I'm fetching data from that database, right? So as a user, I should be able to access this front end, but I should not be able to access that database, right? Because if I start accessing that database, I'll start playing it with that, right? I'll do some here and there. So the database will never be accessed, never will be the publicly accessed, right? So I'm sorry. What we are going to do it, we'll create two containers. One will be application container, one will be database container, and we'll create two different networks as well. Now, one is front-end network, which is the front end, or you can say a public network. This public network will attach to the front-end application so that anybody from the outside they can connect. But there is another network which is called as an internal local host network, which is, you can say, a private network, right? This private network will be attached only to the database. Got it? Now, remember how this application is going to connect this database. It will be connecting via this private network, this internal local host network via this, right? So ideally, this application container should have both the network, right? It should have your public network. So anybody sitting on the internet, he can connect this. And for this application should communicate with the database, there should be internal network as well. Same way, think about Google. So I'm interacting with Google with the public internet, right? But the Google is interacting with a database with their private network so that I am not able to access that, right? So if you talk about Google have two different networks, public and private, right? But if you talk about the database which is sitting behind Google, they only have a private subnet, private connectivity, right? Mine public connectivity will not reach to the Google. Agree?
Yeah.
Right? So same thing we are going to do. I'll create two different network. One is the public, one is the private. We'll give names, such kind of similar name, front-end network, internal local host network, and I'll connect I'll connect both the network with front-end application, and database will be only private network. Okay. Let's crack on. So let's see how it works. So I'll just clean up other things. Just need one machine to be running. Okay, let's come out from everything. I don't need anything. So if I run Docker PS, anything is running? Okay, one container is running, right? Which we have started. So just if you want to keep it running, keep it running. I'll just stop it so that nothing is running, so I can show you properly. Okay, I'll run the Docker PS again. Nothing is running, right? All got shut down.
If I go in the container and exit, that will also shut it down, right? No, it won't.
Yes, it will be.
It will. Okay.
Yep. Okay.
Yeah, you're right. It does shut it down.
Good.
Yeah. Yeah.
Okay.
So if I exit from that container window, it shuts down. Okay. Let's go.
Yeah. Okay, so I'm going to create two different networks. So before that, let's run the command and see if there is any network running already. So I'll run command docker network ls. Okay, so you can see here there is a bridge host none, but these networks are not available. Front end and local host is not available, right? So I am going to create this. Let's run this front end. Got created. And let's create the another one as well. Okay. Now, if you run the Docker network ls again, ideally you should have two different network now. One is localhost, another one is the front end. Remember, localhost is the private network, front end is the public. We can give the name if you want to give, you can give the public and private as well. Okay. How you are going to identify? That's very important. Now, if you see here the network ID, right? Are you able to match it here? So the first few digits will be matching with this. Whenever it is going, it's actually ID, the network ID, but first few digits will be given as a network ID. Okay, so that's a front end. And for localhost, 0F something, this is your, right? Okay, now what we are going to do it, remember, we have to create two different containers, right? One container will be a database. One will be application. So let's create a container for database, right? Now this is the big one. I'll just tell you what exactly it is going to do. Okay, so Docker container run is fine. This you might be aware, right? Now you ask, right? Can we give some name? So hyphen name. If you're using this one, you can pass some name. Okay, Sunil, I think you asked, right? That the can we pass some name specific?
Yeah, there is a yeah.
So if you're using hyphen name, you can pass the name. Then hyphen network. If I have to provide network, remember we are creating a database. Database will be having only private network, right? So this local host we are attaching with the database. So I have given hyphen network is localhost, right? Then we are passing some parameters, MySQL root password. Anyway, we are not going to connect database, but just in case, this is the way actually how you can pass it. And then what is the image that we are going to? So MySQL, I'm going to use MySQL 5.7. That's the database version. Okay, so MySQL is not there locally, obviously, because first time I'm doing it. So it will get downloaded. Okay, so if you run Docker PS, the container is running, right? Now, let's run another container, which is the application one. Okay, similar way, name I am giving front end. Okay, and network I am giving front end. This is the public network, right? That's the same network. And what is the image that I'm going to use? Image I'm going to use Nginx. If you want to use something else, Apache or something, fine. Nginx is also a web server, kind of web server actually that can be utilized. Okay, so if I say yes. Okay, now Docker PS run Docker PS again. Both the container is running, right? My front end app is running, my database is running. Okay, now ideally right now in this situation actually we have just created two different network. We have given front-end network to my web server, and I have given my private network, which is local host, to my database. Correct? Okay.
I'm a little lost on what happened there. So we created one network called front end, right?
Yeah. See here. So we have created a front-end network.
Okay.
Then we have created a local host network, which is the private one.
Okay.
Okay. Two. Then we have created one container network with the we have created one database container actually with the private network.
Okay. And
Now,
then this is MySQL. Okay.
right? It's I have given MySQL as a. Now remember, I was talking to you, right? This is the one I'm creating, database. So database will be having only private network, correct?
Right.
It should not have the front end one.
Okay.
Because database is the behind of your application, right? Behind your front end application. So it should not connect to the public network. Okay?
Not available to the public, right? Yeah.
Okay. Now the next one, when I'm creating my front end application, at this point of time, I'm giving front end network. Right? So both things are good. But one problem is there. If you see this documentation, this one got public network. So, okay, I'm sitting here, I can connect it. This one got private network. Okay. But the problem is, until unless this private network is also connected to this container, they will not be able to talk to each other. Right? So this machine should have both the network, private and public. Okay. So for that, I'll connect it anyway, but for now, let's see the application. Okay, let's see the these databases, how they are working. So if I run Docker inspect the front end app, this is my front end application, right? If I run Docker inspect from front end, and if I go bit up in the networking section, this is the network ID, right? This one is network ID belongs to your front end one. Even though if you want to see somewhere, I think you can see somewhere. Are you able to see somewhere the name front end? Okay, anyway, from this network ID, actually, you can identify. Okay, why I'm saying, remember, when we run Docker network ls command, this is the front end, and front end, network ID is this 1A9D, something like that, right? This is the one it's starting. That's why it's a
not the host name, right? There is also a host name.
No, it's not a host name. Yeah,
Okay.
host name you can inspect actually. When you're doing inspection, right? I'm doing inspection of my. Okay, so this is the front end name. Sorry, I was not checking that. So if you see this networking tab, in the last one, you'll see front end. It means front end network is attached to this container. Right? Same way, if I go and trying connecting the another. Okay, so let's suppose I'll try to inspect the second database, the second container, which is the database, right? Command is I've already given in the documentation. You can run Docker inspect database. Okay, and this database should be connected to the private network, which is the local host one, correct?
Mhm.
If I run it, yes, here you go. That's the local host one, right? So this one was expected. Now, one more thing we have to do it, that I told you, right? This private network should be get connected. This private network, this local host private network should be connected to this machine as well, so that they can talk to each other.
Mhm.
Okay. For that, there is a command called this command. So Docker network connect local host to your container. So if I run command Docker network connect local host to front-end application. Okay. Now, if I inspect it again, I should be getting both the inspect the same application, same container front end. So ideally I should be getting two network now. So there is a front end. Where is the local host? Here is the local host, right? Both the network got attached. So front end and local host. Earlier there was only front end, but now local host also got attached. Clear? This is the way actually how you can play around it. So I'll do history just in case whatever the command I have run. After installation, right? From here. Okay. So these are all the commands that I have run just for your information purpose. Okay. I know that it's not straightforward. Docker is very complicated product, right? So you have to, give some effort there. You have to work by yourself, do it multiple times, try to understand it, what exactly it is doing. When I'm attaching container, what exactly happening, where exactly it is getting attached, all those things. Okay, give a try and you can ask question. Okay.
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 So now what we are saying is that you can, then the front end is able to connect to the database. Database is able to connect to the front end, right? But the database still remains like an internal network, and the front end still remains like a open network, right?
Yeah. So I told you, right? Let's see the example of Google. Okay. Google is the front end application,
Okay.
right? But Google must have their database from where you are getting all the search results, right?
Definitely. Yeah.
Right. Now I can connect Google, but I cannot connect to the database, right? But Google can connect, right? So ideally Google need two network. One via the public network via which we are connecting to the Google, another a private network by which Google can connect to the database.
Yeah.
Got it?
Yeah.
So two network for your front-end application Google, one network for your database. So for database, even though if you're giving just private network, fine. It's public is not needed for database, right? Database just need to talk to Google, nothing else.
Yeah, no, I got it. And then these networks are running independently, and then we have containers, right?
Yep.
So containers are so if I do Docker PS, right, I see two containers running.
That's correct.
And then each container is connected to the associated network, right?
Yep. And how you can check? That's a command I told you, right? The one that I was running, Docker inspect that container name. If you give, you can see what all the network is attached. So ideally, for your front-end application, two networks should be attached. For database, only one network should be attached, which is the private one.
Right. So front end and database, and then we have, yeah, okay, I got it. And then the database that we created is also the name of the network and also the name of the app. For the front end, we put the word app into that. Okay.
Yep. Yep.
Okay.
Naming you can change if you really want to
Localhost, right?
change.
Yeah,
Change the
naming.
name.
Right, yeah, okay. So is there any way I can ping one of those? I should be able to, right? I can like ping to those.
IP
machines?
segregation works in a different way actually. Inside IP segregation works in a different way. So give a try, connect it and then try to ping it. But pinging, ideally, it should not work directly. Actually, there is some firewall will also come into the picture. So because the firewall we don't have, okay, so we need a customized firewall. So sometimes that customized firewall will not be there actually.
Okay.
So that's why the direct pinging will not work. This is a hypothetical information I'm telling you.
These are kind of like virtual networks too, right? Within this machine, right? The network that we have created is a kind of like a virtual network within this machine, right? Or that's something I think that's some knowledge I will have to gain on. What exactly does it mean when we create a network? What does it mean to create?
Yep.
Right.
You can see there different IPs are being assigned. Okay, so I'll show you. Like let's suppose Docker PS, right? So let's suppose I want to
that's already running, right? No, that's already running. You have to go into that, but I think connect was the right thing, but you need like something extra.
No. Running containers, there is a command actually by which you can connect it.
Yeah, I'm googling like how to connect to that container. How do I go inside that container?
No, that Docker run is by default will land you. If just search running container, how you can connect the running container.
Yeah, something like exactly. How do we connect to a container that's running?
There is a command I forgetting actually. Execute. Sorry, yeah. Execute. Docker execute. Execute. -it, I believe so. Docker execute is the command. Docker execute.
Just say Docker execute and then container name.
Bin bash you have to give actually. So Docker execute -it /bin/bash. This is the way actually you can. Yep, you can connect.
Yeah, so you're starting and you're sharing that. Now you are inside the machine, right? Or inside the Docker.
Yes.
Right? If I say you name, I'm gonna find Linux, okay, or the machine name //star IS. What is that file that you get to get the machine name? Because /x3/ /streets.
Hold on. I'm trying to. What is the IP address have been assigned? So if I run the front end, right? So I need to connect. Okay, if I run Docker PS. Okay, what is the IP which that Docker database had? Docker inspect and database. Okay, so this one have this IP 172.19.2.0.2. Okay, if I'll say.
I think you are still in the parent machine. I don't think you are in the Docker.
Current machine will not work. They are in a isolation. Sunil.
But I think there is no bash BSS in that one. So if you just use.
Because that's this machine is just bare minimum actually. I'm not sure if I can install ping.
No, so you think you are inside the Docker right now, right? Docker machine.
Yep.
And if you run like the Docker PS, then it should not know because you are in the Docker inside, so you don't know what other Dockers are, right? I don't know.
No, actually. So why you want to run the Docker PS inside?
No, if you run, then it's still showing you the main thing. It looks like you are still in the parent machine. If you cat that file, right? /sd/ what is it?
No, that's fine. What I'm saying, I'm not doing that one. This one you're saying.
Yeah, if you.
No, that I know that
Please.
we are inside actually, but I'm
Yeah,
trying.
oh, you are inside.
What I am trying
Not
to
on
do.
the Red Hat anymore. You are inside.
I'm trying to ping the IP address of your database from application container actually. Okay. So I need to install it. The problem is ping is not there actually on that machine.
So it's past 7. I have to take off.
Okay, that's fine. Anyway, we are going to shut down for today, Adel. So,
Yeah. See you tomorrow then.
Yep, we'll meet tomorrow. Let's shut down Sunil for today. We'll connect tomorrow.
Okay.
Okay. Thank you. Bye.
Yep.
Thank you.